Well, hello. Welcome to the Physionic podcast, my what seems like once every 3 month podcast that I like to do every once in a while. Really, when I have a lot to discuss, mainly because I can't stick to a once a week or daily podcast. Simply not feasible with my schedule. But if you're in for the long ride, then you're going to be in for an incredibly long podcast that's going to be spanning a whole host of different topics, from the carnivore diet, LDL cholesterol, taurine on longevity, one meal a day, fiber, cancer as a metabolic disease, fasting and inflammation, and then I've got a small section on Q&A because people ask me an overwhelming number of questions. So I've picked out a few from just like 2 or 3 videos. And then I have a few stories that come from the comment section, actually, people that have implemented some of the things that were discussed in video format or some of the content that I've released. And they've reported back with stories of what they've gone through. So I realize that this is going to be extremely long, so there are going to be time marks or timestamps so that you can skip to whatever subject that you're most interested in. But I also often get comments from people saying that my voice is soothing to the point that they fall asleep. So if that is why you're listening to this podcast or watching this podcast, then you're welcome, because this is going to be a good 2 to 3 hours long. Well, it's going to be long. So if you can just put this on repeat, then you'll be asleep forever. Anyway, so yeah, those are the topics we're going to be discussing, and then I'll go into a little bit of housekeeping stuff at the end. If you're listening in the morning, I have my trusty Jovio mug here, which is the prototype mug. I think I mentioned it last podcast. So I'd released this video on coffee and facetiously calling it "Coffee is Killing You," because a certain doctor had said that coffee was bad for you for a number of different, well, really just for one main reason, but then that one main reason catapulted or split into many other reasons. And in that video, I introduced people to my dad's mug, who invented this mug that you put in piping hot coffee, and then it cools it to a drinking temperature within 2 minutes, and then maintains that drinking temperature for 2 to 3 hours without any sort of batteries. So it's just physics, because he's a physicist. So anyway, it's called Jovio. A lot of people asked me after that video released. I put a pinned comment for people to check it out. And I had a lot of people, well, maybe I shouldn't say a lot of people, but I had a few people end up buying a mug from my dad's business, which is a really small business. It's in the basement of his house. So, and it's just a one-man operation. So it's not an enterprise or anything like that. But yeah, so he's able to actually read the notes that people send in, and he got several notes from people saying like, "Oh, I found out about this through this video," and all that. And so anyway, for anybody that ended up buying a Jovio mug, thank you. It really made my dad happy. And I enjoyed getting these notes every once in a while from him. I remember just recently I was standing next to him, and he got an order in, and it came with one of those notes. So I was able to read it in real time. Anyway, though, this is the prototype version, so this is not what the mugs actually look like, but the technology is the same. Anyway, so I'm going to be drinking my coffee as we go through the podcast, and I think, well, sometimes I get complaints from people saying, "Just get to the point." It's like, well, it's a podcast, so I'm probably not going to get to the point. The one place where I think people can avoid brevity is specifically in a podcast where they can just talk at length about particular topics. But that said, I do understand that people are also here for the science and to get some actual takeaways from this. So let's go ahead and jump into this. So let's discuss the carnivore diet. I recently released, actually, I think when this podcast releases, the video will have released either that week or the previous week. And the video is just explaining the carnivore diet. So looking at the science of the carnivore diet, what science there is. And I really say that incredibly lightly because the science that's around the carnivore diet is basically non-existent. We've got many anecdotes from people, but we do not have any real science. We have one study at the point of this recording, but that study was, as I explained in the video, pretty poorly designed. It's also a survey study, which I always find comical that when the survey study is about, let's say, a high carbohydrate diet being, let's say, healthy for you. This is just an example. I'm just throwing something out there before people flip out. I released this a study that says a high carbohydrate diet is perfectly healthy for you, and people are like, they nitpick every little detail about it. But if it's one of the worst designed carnivore studies, or one of the worst designed studies that happens to be carnivore, people have zero qualms with it whatsoever. I got over 1,000 comments on that video to date, which just released, at least when I'm recording this, just released yesterday. I have over 1,000 comments, which is overwhelming, and I'm incredibly thankful and grateful, of course, especially what I'll get into for some of the comments. But it's just telling to me that I feel like the audience has well, I guess I get comments from kind of a wide a breadth of different individuals. Some people that are keto, some people that are kind of lower carbohydrate but not keto, some people that are carnivore, obviously, some people that are vegan, some people that are plant, could describe themselves as more plant-based as opposed to specifically the trigger word of vegan. And then people that just have a balanced diet, either way, which is really great because that's sort of where I want Physionic to be. I wanted to reach out to all kinds of different individuals. But among those 1,000+ comments, I got zero feedback on how bad the study is, which it's really bad. It's a biased sample. It's a survey study. They only had limited data for certain metrics like blood sugar levels, CAC score, LDL cholesterol, HDL, all that stuff, total cholesterol. So they had limited data for that, and then they quantified things in a kind of a semi-categorical method, which was a little strange. So it was just odd overall. But that said, I did say in the video that I believed the study results, even though there were many flaws with the study. And that certainly could bias me, that could introduce a significant amount of bias, I would say. But also just basing this off of the flood of anecdotes that I receive, which is also biased, of course, because you have to think if people are having great results on a particular diet, doesn't have to be carnivore, just any diet, and they have tremendous results on that diet, on that nutrition style, and then people, they will often search for that nutrition style and try to bond with other people that are also having great results or thinking about getting on this diet because, it's kind of human nature to create that bond with one another. So people will go to that video and will post their positive experiences with carnivore. And every once in a while you get a sprinkling of negative comments about carnivore. But overall, it's, if the bias tends to trend toward a positive. So if you have a negative video on a particular topic, people really go in on you because their experience just doesn't match up with what you're saying in the video, even if there may be a significant amount of science behind it. Makes me chuckle, but it's also understandable. I totally, I try to look at it from multiple vantage points as opposed to just basing things off, well, the science says this, so therefore you're wrong about everything. One of my favorite words at this point, which is certainly going to grow as Physionic grows, is the word nuance. I think that there are very few people that really understand that. And when I see comments from people that are really nuanced, especially people that go against their own bias, where they say, hey, I've had horrible experiences. I'm just picking on the carnivore diet because that's what I'm going to go into. I've had horrible experiences with the carnivore diet, but I acknowledge that so many other people have had great experiences. So therefore there must be some middle ground. Maybe it doesn't work for me, but maybe it works for these people. And there may be some physiological reason. There may be some genetic reason. There may be some lifestyle reason. The point is, it can be all over the place. So I really appreciate those kinds of comments. It really shows me the intellect and the conscientiousness of people across the world, which of course is always going to be the case. There are many people that are truly really intelligent and really kind and really empathetic and have a high degree of emotional intelligence. Which, it's an admirable quality, and I think it's something that I admire significantly in people that comment under the videos that have that style of mentality. Okay, so what about the carnivore diet? Let's actually get into it as opposed to talking about the comments. This study came out, and I told you about all the different issues, and I also said that I believed it, even though, and the one thing is that we need hundreds of studies on the carnivore diet. People have been saying, well, they're never going to get funded because the pharmaceutical industry is never going to, okay, fine. That's not actually really the case. You can still get funding for studies. Is it going to be a little bit difficult to convince, like the NIH, hey, so here's our plan. Hear us out here. We want to put everybody on just like a meat only or strong emphasis on meat diet. And that's the study design. The NIH is probably going to look at you a little funny, but if you can have a strong enough basis, they might be able to fund that, or you can go through nonprofit funding or whatever. So funding source, there may be some limitations, but I don't think that they're necessarily like, oh, we'll never see carnivore studies because of that. I think that if you have strong enough rationale, you can have a study that's publicly funded. So we need to wait until we have many more studies to really get a clear image of how the carnivore diet affects our health. And my definition of the carnivore diet, which is of course variable. Some people mention, well, this influencer, this person does the carnivore diet in a slightly different way. The way that I've defined it, and I think we can largely agree, is that the vast majority of the consumption is meat-based, with very little, if any, in certain cases, it's like essentially none, vegetables or fruits or anything like that. Other definitions would include things like honey or including certain fruits and whatnot. But by and large, although there are certainly differences between the two, I think that the key there is the high protein, the high animal-based foods that a person ends up consuming. So with that definition in mind, I think I even said in the video, and I ended up releasing a public post. I've been releasing little like articles every week for the public community, alongside with my insiders content. So I've been releasing these public posts that kind of color in added detail offer maybe a slightly different, a little bit more information that I don't necessarily cover in the videos. So if you're interested in that, it's completely free. You're welcome to join the Physionic community. The free version, which has every week, like I said, I've been trying to release some sort of post that offers more information. But anyway, so I talked about the carnivore diet in my public post or my article, and essentially it's really difficult for me to sit here and say that I try to be as unbiased as possible, to say that I also believe this study, the results of this study, also based off of the number of certainly biased anecdotes headed my way through hundreds of comments, and then for me to say, oh, the carnivore diet is just bunk. I just can't do that. And the reason is because the results are really pretty remarkable. I mean, if you go from a standard American diet, a SAD diet, which is always a funny abbreviation in my mind, SAD, it's just so fitting. So the SAD diet, the standard American diet, you go from this degree of hyperpalatability, these packaged foods, everything is specifically designed to make you crave more of it, to feel the least level of satiety, to spend more money. I mean, it's just like it's particularly designed exactly for that purpose, to make it as appealing as possible so that you consume much more of it than you necessarily need. And you go from that to strictly just the consumption of one or maybe two things. I don't think that the carnivore diet, and I said this in the video, is some magic formula that meat is somehow the fix for all health woes. But because it's so simple to follow, it's like, are you eating meat? If the answer is no, then you're breaking the rule. Simple as that. And again, depending on the iteration of the carnivore diet. So the way that I interpreted it as that these people are getting these massive results, these huge, like we're talking about, I don't want to say reversal, but the significant reduction in diabetes symptoms, talking about reduced like A1C, looking at reduced blood sugar levels, reduced insulin levels, looking at different other metrics. I think triglycerides may have been one of them that also decreased. Also, people just losing a tremendous amount of weight. So a lot of people experienced weight reduction, but additionally, they were able to also recover some of the other deficiencies that they'd had. And there's a whole host of different disease states that they were able to at least better, if not completely reverse. And again, I don't sit here and think like, okay, well, it's because of something in the meat. It's legitimately because it's an elimination of everything else. So if you literally eliminate the standard American diet, what's going to happen no matter what direction you go? The answer is most likely that you're going to see significant improvements. So that's not a huge shock. And some people report that, they've been using a carnivore style diet for, a number of years and they feel fantastic. That's great. I think that where the nuance comes in again is that people think that if they're on this one diet, again, it can be any diet, but we're going with carnivore here, that if they're on this one diet, that it must be magical. It must be beneficial in every single way, that it can have zero downsides. It must be all good because they've experienced so much good from it. Therefore, there's no way that there could be any sort of possible negatives on the other side. And the reality is that there are possible negatives on the other side. Some of them are things that I have not investigated to any great depth yet, like the cancer risk with increased meat consumption. Before you jump down my throat, I realize that, again, that's association. But still, it's something for me to investigate. Specifically, I think prostate cancer was one of the big ones, but possibly some other cancers as well. So, look, like, That's a possibility. But the other thing, even in this study that I mentioned, they even showed, even with their poor design and everything, that there were increases in LDL cholesterol. Most likely, they didn't report this, but most likely these people have increases in ApoB levels. So those are heart disease risks, as much as people don't want to believe that LDL, or some people, I shouldn't speak for everyone, some people don't want to believe that LDL is a risk factor for heart disease, which I'll be getting into next. And so there is a trade-off there. You know, if you experience significant benefit from the carnivore diet, which I completely acknowledge, you get 90% of the good, and then you get 10% of the bad, and some of it may be really bad. So, and could the let's take a person, let's clone a person. We have one person, we're cloning them into two, so version 1, version 2, and version 1 continues with the standard American diet. The other version goes with the carnivore diet. The carnivore diet then leads to weight loss. It leads to improvements in insulin resistance. It leads to improvements in triglycerides. It leads to improvements in all kinds of different metrics. Okay, great. But on the other hand, it increases the LDL cholesterol. Well, let's say for the standard American diet, you have you maybe not, maybe you don't have as high of LDL cholesterol by comparison, but you have increased risk of diabetes, you have increased risk of all kinds of other issues like weight gain, like obesity. All those things tend to increase with the standard American diet. Well, look, the carnivore diet just eliminated a number of different factors, but elevated one factor, or elevated 3 factors, but got rid of maybe 15 other factors. So like the risk reward there is, yeah, you have to think for yourself, well, what's the risk reward there for myself? Is your risk of cancer possibly higher? Well, possibly, because of the meat effect. Again, something that I still need to investigate. I've just peripherally looked at it a little bit, but let's assume that that's the case. But you know, I may have to adjust in the future. Let's assume that that's the case. The risk increases in terms of the meat consumption, but then again, keep in mind these people have lost a bunch of weight. So could it offset? Could there be an offset there where the risk may increase in one way, so one risk factor increases, and that's something that I think so many people just they cannot seem to wrap their heads around this, and I've said this many, many times in my videos now, that everything is multifactorial. So I always make a specific point to say this is a single factor of many factors. So the increased LDL is one factor for heart disease of many factors, but then the benefit is that you see a reduced body weight. Well, that plays in favor. So you reduce your risk of heart disease in that situation, even if you have an increase in the LDL, which is a factor for heart disease. Then if you compare that to standard American diet, everything is still elevated, even though it may not increase LDL quite as much. It's probably still increased. And then you have all these other factors like the person's severely overweight and just continues to be overweight. Those are issues. I mean, those are things that I would say probably the net effects is that the carnivore diet is more beneficial than the standard American diet. Again, but all these things are contingent on just, we need more studies. We absolutely have to have more studies to really be sure and to be able to look at hundreds and thousands of people that have gone through this and be able to start teasing out that data, statistically speaking, as opposed to me just using educated guesses to come up with some of these conclusions. So my interpretation of the carnivore diet up to this point, and I said this in the public, in the article that I wrote, is that I think it could be, and this sounds so crazy to me because I never actually, I just thought it was the stupidest idea ever to just eat straight meat. But let's put that aside. You know, after I thought about it some more and all these people reporting their benefit and then reading this study, as flawed as it was, for like the 5th time, I thought to myself, well, look, if people find it easy to stick to, that it's sustainable for them, that they need that extreme. They need that extreme of just cutting everything out and just sticking to one thing. Then I think the short term is that it's a net benefit, the short term. But I do think that people should be encouraged then to slowly start reintroducing certain foods and do it in a systematic way that ultimately leads them to be able to take notes and make sure, oh, wait, I started introducing yogurt into my diet and I start feeling really crappy again. Okay, well, now this is like cause and effect. Like you're literally introducing a single food for, let's say, a week or 2 weeks or a month, and you start feeling worse suddenly. That is cause and effect, because nothing else should be changing. If you're doing it systematically, that is. A lot of people just throw everything back in. That's not how you're supposed to do it. You're supposed to slowly add one food at a time back into the mix. So it's a delicate process and it takes a lot of effort. It really does. And I get that a lot of people don't want to put in that effort, but that's what is required. So you hop on the carnivore diet, you reap all the benefits for X amount of weeks or months. You have to excuse some of the sounds that you might hear, the city life, unfortunately. And then from there, after you've reaped the benefits of the carnivore diet and you start really feeling good, you should probably start introducing some of these other foods and maybe start lessening your meat intake, because that way then you can reap the benefits of everything as much as possible, which ultimately leads us to a balanced diet. But the caveat here with the balanced diet is that you've removed the elements that for you specifically were A, trigger foods, B, allergens, 3, they may have caused an autoimmune reaction. Like there's all kinds of different things that, because you've gone to this baseline and then slowly built your way back up, you have taught yourself your own nutrition. That's so cool, first of all. And secondly, that's how I would probably think of using the carnivore diet. Would I stick to it indefinitely? Probably not, because I still think that the risk is pretty high. And then this is an area that I have absolutely zero expertise in, no real knowledge about, but people that are more knowledgeable than I am, far more knowledgeable than I am, have said that it is also not sustainable for the planet. So if that's true or not, I don't know. But if it is true, then that may be another reason, instead of having everybody just consuming loads and loads and loads of meat. And then, of course, some people have issues with the ethical reasons, which I completely understand as well. So that's sort of my take. I'm saying sort of because it's so much uncertainty there for me, because I have a lot to learn. And I think that there's so many holes that have yet to be filled, that if you are listening to someone and they are telling you, oh, these are the absolute truths about the carnivore diet, I just have to call BS on that, because there's no data on it. So it's just not responsible to say, oh, even if they say, oh, I've been doing carnivore for X amount of years and I feel great. Good for them. That's still an N of 1. I mean, that's always an N of 1. If that's negative or positive, I did this, I felt horrible, so therefore this study is BS. That's an N of 1 versus a well-controlled study. Or on the opposite end, also true. I did this and I feel great, therefore this study is BS. It's like, again, the exact same syndrome occurs, where it's an N of 1 versus a well-controlled study with statistics applied, with controls applied, all that stuff. So yeah, so that's my take on the carnivore diet. There's a lot more data that needs to come out. That said, one more quick thing. I received, like I said, over 1,000 comments on that video as of yesterday, or like that just released yesterday at the time of this recording. Or as I'm recording, not when it actually releases. And I specifically put in multiple addendums and just like these disclaimers in there, because I often get just rammed with tons of comments telling me off for being stupid, or telling me off that I don't know what I'm talking about, or whatever it is. And while many people like to attribute that to the vegan individuals, which I really hate to put everybody in this camp of like, well, if you're vegan, then you must be some sort of fanatic. I don't believe that in the slightest. There are certainly some people that are really fanatic and they are vegan, but I thought that for the carnivore individuals as well, just because I've experienced that so much with the keto individuals. There have been many, many keto individuals that have told me off for all kinds of different reasons, which 99.9% of is completely baseless, and it's just nonsense. People that don't have any like sense of context and don't have the ability to dissect the data that's in front of them, they just ignore it, just blast through it, and just insult, or they just say, well, what about this study? It's like, okay, well, one study, 15 studies showing the exact opposite. Like there's something there. We should investigate the one study, but the 15 other studies, we can't just ignore all that data. It's not like I'm going to bypass all that data and just focus on this one study. We have to look at the body of literature. So yes, let's look at that one study. But if you were going to present this one study, it's up to you then to look at the data that I presented in the 15 studies and come up with an explanation. And usually if it ever gets to this point, the explanation is something along the lines of like, well, they didn't look at triglycerides. It's like, okay, hold on. Like 4 of the studies did look at triglycerides, so that's not an argument. And they still found the same results. It's again, nuance. It's a conversation that needs to happen. It's critical thinking abilities that really need to be developed for some individuals. But that all said, I was fully prepared to get a flood of those kinds of individuals that were going to tell me off and just insult me, which again is fine. I ignore the comments for the most part. But so I put in all these disclaimers, and I have to say I'm blown away by the kindness and the thoughtfulness and that conscientiousness, that nuance that people had. I mean, I'm literally talking about 1,000 comments, and the vast majority of them, I'm talking vast majority of them, were carnivore people that were like, yeah, I've been doing carnivore for 3 years or 3 months. I've been feeling great. And, but I think that the way that you presented things was really like balanced and whatnot, which, I was trying to do, but it's not because I was like, I have to be balanced. It's more just like, this is what the data shows. So this is what I have to report. It's not that I'm trying to get in the good graces of the carnivore people, because I don't care. I'm never going to be carnivore. I can promise you that I'm never going to be carnivore. Unless, knock on wood, I have some sort of autoimmune disorder and I'm at my wit's end and I can't figure out how to deal with it. But overall, I'm very satisfied with my nutrition. So yeah, it was really remarkable, really touching, and I deeply appreciate the comments that I received. Not just talking about me. I'm just like specifically talking about the video information. And people just having that nuance of like, yeah, I've noticed my LDL is raised. But in totality, I feel so much better that I would rather just feel better and then have a potentially slightly higher heart disease risk. That's okay by me. And it's like, that to me, that is such a mind-blowing level of conscientiousness and ability to contextualize data and apply it to your life. Like, kudos, seriously, kudos. You rock. You seriously rock. When I comment, you rock and stuff. Like, this is how I feel. I'm just freaking amazing. Freaking amazing. Okay, let's move on to LDL cholesterol. This is actually, let me grab some coffee real quick. Okay, LDL cholesterol. Oh man, this is one of those topics this is one of those topics where people feel they just know all the information about it already. And I'm sitting here I'm trying to piece together like 20, 25 different studies on the topic. And it's taking me a long time. It's been like, I don't know, maybe 2.5, 3 months of work. I covered LDL cholesterol specifically. I covered the sizes of LDL cholesterol. I'm going to be covering in the very near future, I'm be covering the oxidation of LDL cholesterol. I'm going to be covering inflammation as well. That is not something that I've touched on at all. I still need to read those studies. I have like 4 studies or reviews put together, so I still need to go through the oxidation of LDL. Currently working on putting all the data together. I think I have 6 or 7 studies that I've collated, I've read, analyzed. I'm putting together the graphics so that people can see what the studies say, like the actual mechanisms and whatnot. So I'm working on that. I'm hoping that'll be out at some point. Maybe I'll record that tomorrow or the day after, and hopefully it'll be out in, I don't know, a few weeks. So this is an area that I've spent a lot of time reading and trying to understand. And it's not, again, none of these are areas where I just rely on my education and I just think, well, my professor said this, so it must be true. And don't get me wrong, I trust my professors. But again, the point of Physionic is not to rely on my education solely. Like, certainly it's a part. Otherwise, what's the point of me getting my PhD? Or what's the point of me getting my master's? I mean, I want you to have some faith that I know how to read research. And those are the skills that I've learned throughout my education. So that's great. But it shouldn't be based off of like, well, I have my doctorate, so therefore you should just listen to me. No, right? Physionic, I always go forward into an analysis with the idea of like, I may have an idea of like what my professors have told me. Absolutely. So there's that bias, that initial bias. And it is tough. There are times where I run into conflicting information because I do try to listen to what other people have to say, some kind of a little bit fringe individuals. And I try to look at the data that they present. And oftentimes it's kind of a nothing burger. And the reason why I say that is because once you aggregate all the data together, put all this information together, and look at a swath of studies, you start seeing trends. You really start seeing trends. Or if there's some confusion, if there's a lot of disagreement, a lot of heterogeneity between studies, you start to look for the different factors that may be like explanations essentially for why, and then I try to separate out the data based off of that factor, and then sometimes there's still some problems, some confusion, so I look for another factor. It's like it takes work, but it's always with the idea that I need to have some real data, some solid data to explain or to show why I'm coming to the conclusion that I am. And if I can't, then I essentially just throw up my hands and I say, there is a factor that we're missing here that we need more data to be able to triangulate what that factor is. And that hasn't happened very often. One of them was sucralose. My sucralose investigation. I think that there's a lot all over the place in that world. But LDL is not one of them. It's simply not one of them. There's so much data. I mean, I think people think that it's just like we have like one study that shows that LDL is a risk factor for heart disease. People will often report or like comment and say, well, it's all association. All of it is association. It's like, no, it isn't. No, it is not. There's a tremendous amount of data. Yes, some of it is association, absolutely. Some of it is association that's bolstered by multivariate analyses, which I think people just have zero clue what that even means, but they just hear the word association. They're like, well, it's association. It's like, there are ways of making associations a much stronger, much closer to causation, not causative, not that association suddenly becomes causation, or correlation becomes causation. Not saying that, but it becomes you start eliminating other factors, which by these huge data sets, and it's actually an area that I need to educate myself further on, because I need to know more about epidemiology. I know some, but from just reading and educating myself, but I need to get some more formal training in epidemiology, and I certainly expect to do that. Hopefully, once my PhD is over, I think I'm gonna. I may try to find a way to get a mentor in that area, and see if I can learn some more. But anyway, with the limited information that I know, which is it's not nothing, but it could be higher. So we have associative studies. We have associative studies with these univariate and multivariate analyses. Then we have, on top of that, we have the familial cholesterolemia studies. Then on top of that, we have the randomized, or the Mendelian randomization trials. It's there. And then we have the statin trials. Oh shoot! Now we're going to get a lot of comments on that. I haven't looked into statins in any great depth. I still need to do that. I know a lot of people ask me. It's just, I'm a one-man operation. It's a bit tough for me to cover everything. But the point is that there are multiple lines of evidence. That's just the lines of evidence. I just listed like 4 different lines of evidence. That's not even talking about the studies within them, where there's like 50 studies. And even if a person comes up with one study that shows that LDL isn't related to heart disease, it's like one study, 50 studies. It's so strong. It's so strong that LDL is related to heart disease. So yeah, you should reduce your LDL levels. Try to. And then people, of course, then mention the U-shaped curve. No one's denying that, but there are explanations for that. Like, for example, why low LDL, people or at least studies that show that low LDL is also associated with increased mortality specifically, is the explanation for that's been teased out in the data is that individuals with low LDL tend to suffer from chronic illnesses. Those chronic illnesses suck up cholesterol. Like a great example is cancer. So a lot of cancers will sequester a tremendous amount of cholesterol, take it out of the bloodstream, and will use it for synthesis. And so there you're talking about a correlation. So the correlation is that low LDL is related to increased mortality. But the covariate with that is, oh, by the way, these people have cancer. And these are all areas that take a tremendous amount of data and take a lot of, again, I'm going to say it, nuance and context and really understanding what's going on. And I'm not saying that it solely relies on that. It's not just cancer. Like, there are other diseases as well that sequester significant amounts of cholesterol. So yeah, just in general, lowering LDL. Now, that said, is LDL a perfect marker? Is it better than like ApoB, for example? Again, I haven't done my deep dive investigations of ApoB. I certainly plan on doing that. But the answer is no. I can say that relatively confidently at the moment, because I, just peripherally by reading these LDL studies, they've mentioned ApoB many, many different times. So the answer is no. If the better marker is definitely ApoB over LDL, but LDL itself is a risk factor because it is so abundant. It is a huge proportion of the ApoB family, so it makes up a huge proportion of ApoB. And I guess I should explain that, the relationship between the two. LDL, so low density lipoproteins. I really should have mentioned that earlier. I'm sorry for the podcast if you're very confused, although I imagine you've heard the abbreviation LDL before. LDL is low density lipoproteins. It contains, for example, cholesterol esters inside of this vesicle, this vehicle, this packaging unit. And the packaging unit is the LDL. It's the lipoprotein. So it has a core inside of that lipoprotein that contains the cholesterol esters and contains like triglycerides and things like that nature. Those then deliver those different nutrients, the cholesterol and the triglycerides, to different tissues across your body. So it is necessary. That's another argument that I hear often is like, well, we need LDL. It's like nobody is saying we don't need LDL. No one is saying we don't need LDL. That isn't the argument, though. The argument is having elevated LDL. And elevated LDL, from the little research that I've seen, is you start showing that there's a relationship between atherosclerosis, or the buildup of plaque, and LDL levels. If you are at LDL levels of, I think, 70 to 80 milligrams per deciliter or higher, you start to see that effect. Is it a danger? It's not really much of a real danger until you get into, I think, like the 100 milligram per deciliter range. Would it be better to be on the lower end? Absolutely. But the higher and higher you go, the faster and faster the atherogenic process could occur, depending on other factors as well, which those are usually also considerations, but those are things I'll cover in the future as well. So LDL carries these cholesterol esters, the actual molecule of cholesterol, to these different tissues and whatnot. So it is necessary, absolutely. However, what happens is that across your vessels, your blood vessels, they're lined with endothelial cells. That's the very outer section. So that's the part that the actual liquid blood is rubbing up against, is the endothelial cells. Then from there, right under the endothelial cells is this tissue layer, which is actual structural tissue. So it's like collagen and proteoglycan, so structural tissue. And those have if I remember correctly, either a positive charge or a negative charge. So now we're getting into chemistry. And the positive and negative charge, whichever one it is, I can't remember which one. If you're interested, you can check out my LDL video. It's lengthy, but you just look at the mechanisms of action. I mention it in there because it was fresh in my mind. So that's correct in there. And the positive or negative charge that each one has, that attracts the opposite charge that's found on the LDL. And the charge comes from the ApoB protein. So the ApoB is found on the LDL. And the LDL then has a ton of this ApoB all over it. Just like VLDL also has ApoB on it. IDL, so intermediate density lipoproteins, also have ApoB. So all of those would be attracted to this proteoglycan mixture, this protein that is a structural protein that is found in your arteries and veins and whatnot, but more specifically in your arteries. A lot of it is found in your arteries. And that ultimately attracts the LDL out of the bloodstream into and past the endothelial cells, which ultimately then binds to the proteoglycans. And then as that builds up, then you start to have issues. That's the initial step of this progression. However, what also has to happen is that you have to have enough of this LDL that's found. And in the bloodstream, if there are very low levels of LDL, the dissociation, the LDL can dissociate from proteoglycans in that it gets attracted. And it's not like molecules. It's not like if I put my phone down, it's just stuck there. It just stays there. In the body, or really when you look at molecules in general, they're constantly fidgeting back and forth. They may be interacting, but they're constantly fidgeting back and forth. And there are times when something can dissociate from another molecule. So if the LDL lipoprotein dissociates from the proteoglycan, then it can return back to the bloodstream. And therefore, you have this kind of seamless exchange of some LDL is attaching, some LDL is then removing itself or finding itself back into the bloodstream. And that happens at very low levels because the concentration isn't high. So you can have this easy dissociation and reassociation back and forth. However, the idea is then if you have higher LDL, now you have more LDL that's around and more of it is associating to proteoglycans than is dissociating. And therefore you start to have this buildup of LDL that's found attached to proteoglycans. So that's the first step of this whole process. And this has been pretty well characterized. I mean, we've got mechanistic studies as well. That's another criticism that I hear. Well, there's no known mechanism. It's like, that is such bull. It is such bull. Like, people just say things and they have zero clue what they're talking. It's remarkable. It really is remarkable how much. Anyway, I'll put that aside. The point is that we also don't really care about mechanisms until we actually figure out what the clinically relevant outcomes are. It goes outcomes first, then we figure out the mechanisms. There's no point in us focusing hyper vigilant on these teeny tiny mechanisms if the outcome is null, if there's no outcome, like there's no health risk, there's nothing that we can detect. Well, then why are we focused on these mechanisms? There's no point. So we've established the outcome and we've also established many of the mechanisms, but we haven't established all the mechanisms. But that doesn't mean that we haven't established some of them. So that's one of the mechanisms to explain this relationship. But beyond that, people have also talked about looking at the different sizes of LDL. So this is something else that I investigated in my initial investigation of just LDL, looking at small, dense LDL versus fluffy or large, buoyant LDL. And people have said, well, okay, I will acknowledge this much, that LDL may be a heart disease risk, but it's only the small, dense LDL. And here's where things, I think that I would say we need more data, or I just haven't run across enough data on it. And I think at this point, I would potentially agree that small, dense LDL are a greater risk, but not that large, buoyant LDL are no risk. Large buoyant LDL can be oxidized. Just to be clear, people, like, one of the major steps after LDL passes or goes through a process called transcytosis, passes through the endothelial layer, the cells, and then attaches to proteoglycans, is that you have an oxidation process of the LDL particles, these lipoproteins. So that is one of the key steps that's been known to be extremely atherogenic. It leads to a further the next steps of atherogenesis and the next steps of heart disease risk or cardiovascular disease risk. So people say, well, small, dense LDL are the only ones that can be oxidized, and that is actually not true. So large, buoyant LDL can be oxidized, but they are less likely to be oxidized. So yes, it is true that small, dense LDL are far more likely to be oxidized, but it's not necessarily accurate to say that, well, if you have large, buoyant LDL, then you don't have a high risk. You don't have a risk of heart disease. And that, while I will acknowledge that I think that there's some more research that needs to be done for this, because I'm looking for certain aspects, certain factors that haven't really been investigated enough to really tease out the differences between the two. I 100% acknowledge that small, dense LDL are a problem. I'm also strongly leaning that large, buoyant LDL are also a problem, but there may be an increased risk between the two. There seems to be probably an increased risk with the small, dense LDL. However, I could still be swayed once I go into a little bit more literature on the topic. But the reason why I say that there's increased risk is based off of a study called the MRSA study, I believe, is, if I remember correctly. It's been about a month since I read that study. And they tried to tease out the differences, and they said that both types of LDL do cause issues. So size doesn't matter, or size may matter, but no matter what, your total LDL particle amount is going to be the first thing that you should look at. Then the second thing that you may want to look at is the size of your LDL. And the size of the LDL, if you can maybe swing that more towards the larger type, that's great. But overall, the particle number is absolutely the number one thing that you should be focused on. Okay, so LDL, the relationship to ApoB. Again, ApoB is a better marker overall, but since we were talking about LDL, and I'm sure that's not going to sway anyone that doesn't believe in LDL. That's perfectly okay. But there needs to be evidence, and not just new evidence. There needs to be a recognition of the evidence that's already present and try to assimilate that evidence into the new evidence, or the new evidence into the old evidence. We can't just ignore all those studies and just say, oh, well, it was industry funded. It's like a lot of those studies were not industry funded. So that's another factor. Anyway, let's move on. The point being, the big takeaway here, LDL cholesterol is a consideration. It is not the only consideration of heart disease risk. And there are better considerations like ApoB, of which LDL belongs to the ApoB family because of what I mentioned with ApoB proteins being found on LDL particles. Okay, so the next thing, I guess one more thing I should say on this, and I talked about a little bit, I alluded to it. So LDL cholesterol, people get their measurements of LDL cholesterol. I released a small article on my on the public Physionic community, and in that article I specifically, and I actually mentioned this in the video as well, the full study analysis, but what we get measured in our bloodstream, so when we get blood measures taken, is LDL-C. And there's plenty of content that's been released out there, and I agree with that content, saying that, okay, well, we're looking at LDL-C, which is a measure of the cholesterol esters. It's looking at the molecules of cholesterol, not at the lipoproteins themselves. And while LDL-C can be an okay metric to look at, it may not always relate causatively to the number of particles. We're not as interested in the molecules of cholesterol. We're interested in the vehicles, the lipoproteins themselves. So in that regard, it would be better, if possible, and it would be a far more accurate measure, to not look at LDL-C, which is, again, that measure of cholesterol molecules. And then the idea is that, okay, well, if high LDL-C, then therefore we must have high levels of the particles, because to carry all that LDL-C, you have to have a lot of the particles. Well, that's fair, but you can also have larger LDL particles which contain more cholesterol, and therefore you would have fewer particles. In general, though, if LDL-C continues to climb to astronomical levels, you're going to see increases in the lipoprotein number, because you simply need more vehicles to be able to carry all that cholesterol. But the other factor is on the opposite end. If you see really low LDL-C, there's sort of a threshold that's, like, I think below, like between that 170 milligrams per deciliter. I mentioned this for the Physionic insiders. There's some evidence, some evidence saying that we need more evidence, but some evidence indicating that if the measures between 100 milligrams per deciliter and 70 milligrams per deciliter, if you just based it off the LDL-C numbers for that, let's say you're at like 85 milligrams per deciliter, you could still have pretty high levels of the particles, even though your LDL-C is in the normal range and is in the okay range. You could still have elevated levels of LDL particles. That's because you would have more of the smaller versions. So in that scenario, yeah, you would absolutely want to get a test to make sure that your LDL particles are within the normal range as well. See, so if possible, ever try to get the LDL-P test as opposed to LDL-C test. LDL-C test is an okay measure. It'll give you some information. It may, like, you're probably relatively safe, but to be absolutely sure, you should get your LDL-P test. Okay. All right, let's discuss taurine and longevity. So this came to me through social media, actually. So there are a number of different videos that started popping up about taurine, and I had no idea why until I watched a few videos, and the creators of these videos were talking about this particular study that had released in June of 2023, so about a month and a half ago. And this study comes out of the esteemed journal Science. I know some people, I get comments sometimes of people being really triggered by the fact that I mentioned that particular journals are esteemed or especially better than other journals. And unfortunately, that is truly the case. You know, Science, Nature, Cell Metabolism, all these different journals are really top tier. And there's a good reason for that. Their peer review process is a lot more stringent than it is for other journals. Not to say that other journals are poor quality, although certainly some of them are. So it does matter which journal you end up publishing in, at least in terms of what you hope is the rigor of the research that's being done. Sometimes you submit to a really high impact journal like Nature or Science, and the reviewers, you don't just have 3 reviewers, sometimes you have 4 reviewers or 5 reviewers, and those reviewers will often ask you to do additional many revisions of more of research to essentially prove what you've already proven. They essentially ask you to do more experiments to prove the same thing. So there's a lot of work that goes into publishing one of these studies, and you can see that in the study that was published in Science, specifically on taurine. So what the researchers did is and that isn't to say that in the journal Science there aren't studies that can get by that are, let's say, fabricated, for example, but overall, by and large, studies that are published in these journals tend to be really much higher impact and tend to have a lot more, I don't necessarily want to say credibility, but a lot more work behind them. So what did the researchers do of this study? They looked at a number of different animal models. So they were looking at mice, they were looking at monkeys, they were looking at humans, C. elegans, so looking at worms, and looking at yeast. Oh, and fish. They had a genetic model for fish as well. I'm not going to go into all the data again, but I'll cover the highlights, because they did show markers, or looking at specifically longevity as well as health. So looking at a number of different markers for health. And what they ultimately found was that to start out, that in mice, monkeys, and humans, that we see drops in taurine levels, blood taurine levels, with age. So by age like 40, 45, we have about half the amount of taurine in our blood that we did at the age of like 5 or 10. So, and that's consistent across the board, if that was in mice, if that was in monkeys, or if that was in humans. And then, of course, because looking at longevity data in humans is really just associative, because for the most part, we can't have people be in a controlled environment for 80 years of their life and see if their longevity is somehow better. I know a lot of people sometimes ask me, like, well, how does it affect longevity in humans? It's like, well, it's the only way to tease that out is through rigorous associations. That's it. We can't do randomized control trials on humans in that regard. We can look at health metrics, but we can't look at overall lifespan. So we have to rely on association studies. Anyway, though, they ended up looking at mice and supplemented these mice with taurine, and ultimately found that the mice that were supplemented with taurine, no other nothing else was different. Everything else was the exact same. So the mice that were supplemented with taurine had identical conditions as the mice that were not supplemented with taurine. And ultimately, the researchers found that these mice ended up living 10 to 12% longer. So that applied for male mice and for female mice. They separated out the data. What was especially interesting was that they gave these mice taurine at middle age. So it wasn't that they were supplementing throughout their entire lives. They were actually not supplementing with taurine for half of their life, and then they started supplementing with taurine. So and that ultimately led to an improvement in longevity. So they ended up living longer, and the non-supplemented mice tended to die earlier as well. So it had an effect on the minimum as well as the average. So there's that was really intriguing. Now, of course, that's animal data, but then they did a number of different metrics, looked at a number of different metrics in health, looking at like insulin resistance. There were mild improvements with taurine supplementation. They looked at longevity in fish that had the taurine transport gene knocked out, meaning that these fish, even if they were to consume taurine, they could not use the taurine because it would not end up in their body, because the transporter that allows taurine into the body was knocked out, meaning that they had mutated it or simply cut it out of the genome of these fish. And so it's the opposite effect. So trying to see if there was a reduction in lifespan, and they found that to be the case as well. So there's two different sides essentially showing that taurine has an effect on lifespan across a multitude of different model species. And then they looked at bone mass, they looked at muscle strength, they looked at all stem cells, they looked at senescent cells, and they found, what I found most convincing was senescent cells were reduced due to a marker known as beta-galactosidase, which is a marker of senescence. And senescent cells, if you're not familiar, are essentially zombie cells. They're cells that aren't dead, but they've essentially shut down. They've reprogrammed themselves, genetically speaking, to express new genes. So they have a certain set of genes, and instead of expressing half the set of genes, they express the other half, and those genes essentially shut down the cell, so that the cell is in a quiescence state. And that's to essentially avoid cancer, because if you have cells that are aberrant and will start to multiply rapidly, that's cancer cells. So one of the mechanisms by which our body negates that is by producing senescent cells. And these senescent cells are then eliminated by the immune system. The immune system will come in and, in a programmed way, systematic way, eliminate those cells. So the benefit is that you get to avoid cancer, but the other thing is that if you have an overabundance of senescent cells, they can actually affect the surrounding cells that are not senescent and turn them senescent, and that's one of the reasons why they're called zombie cells. So these senescent cells, what they found with the taurine supplementation in these mice is that there were significant reductions in a multitude of different tissues of senescent cells. So they're reducing the senescent profile. On the other hand, they showed a little bit of data that I found a little bit less convincing, looking at a gene that is specific to stem cells in skin and in the intestines, and they found that there were more expression of this gene in the intestines, therefore implying that there were more stem cells. So stem cells are the most powerful cell in the body, in that they can turn into a multitude of other cells and can replace the old dysfunctional cells that we unfortunately end up accruing with age, or with bad habits in general. So there were many, many different benefits of taurine looking at health, but of course, obviously also having an effect directly on longevity, the amount of time that the animals were able to survive. And then they looked at the correlation in humans, so looking at another study, so looking at a large data set of humans, and tried to find the association between blood taurine levels and a number of different health metrics, looking at LDL cholesterol, C-reactive protein, diabetes, obesity, all these different areas. And they found that for with blood taurine levels, if they were higher, then you had lower rates of obesity, lower rates of diabetes, and I think lower rates of C-reactive protein. However, what was interesting is that the inverse was also true, that if you had higher blood taurine levels, that there was was associated with increased LDL and increased ApoB, which is what we just talked about previously. So that was a bit of a worry. Ultimately, I can tell you that I did end up looking at a few analyses looking at supplementation of taurine in humans, and they actually found that was not the case. So I don't know what was going on with that association, but that's a perfect example of when you have an uncontrolled association. So you're not doing these other analyses, these other additional analyses like the multivariate analyses that I mentioned earlier, that then it's really difficult to tease out, well, why is there that association? And unfortunately, this was just a straight, plain association, and what they found was that inverse. So there's probably some other factor that's involved, and some people mentioned that, which I think is possible, I haven't really looked into this, but that people that eat more meat may have had elevated LDL and ApoB, and therefore they may also have high taurine levels. So it's a balancing act. It's tough to figure out, but the actual supplementation of taurine, what I did find across one meta-analysis, is that at least it did not increase LDL. It may have had a slight reduction in LDL, but for sure it did not increase LDL. So the direct effect of taurine did not increase LDL. So I think for the most part, I would dismiss that concern now. And I think I added an amendment to the videos that I released as a result as well. So taurine supplementation, an interesting area. Do I think that taurine is going to suddenly extend our lives by 10 to 12%? It's animal data. It's always really interesting, and it's a good first, or kind of I would say, second step. I think in vitro research is the first step. Then you go to animal studies, and then we need human studies. And the only way to get to human studies is to get to essentially retrospectively, or maybe prospectively, so retrospectively looking back at people that have been supplementing with high levels of taurine, and essentially tease out, do they die earlier or do they die later, in life compared to people who don't supplement with taurine? So, but that's all strong statistical association kind of studies. So we're probably, I don't know if we're going to get that anytime soon. So we'll see, but I'm not 100% convinced that taurine supplementation is suddenly going to lead to longer life or anything. But could it? The evidence is starting to point that way, but we need a lot more to really be certain, especially in humans as opposed to animal studies. And there's some added context that I applied for the full version of that analysis when I was talking to, again, the Physionic insiders. But by and large, that's my take as it stands. So now let's move on to one meal a day. So one meal a day is really easy concept. You just eat one meal. How often? A day. So it's really just that. And what I ended up pulling together, I think, 4 studies, which is like all the studies I could find on the topic. And unfortunately, most of the studies had people maintain their weight or try to maintain their weight, which is not the best way, or not the most applicable way, I suppose I should say, for looking at one meal a day, because I think most people that use one meal a day are trying to lose weight or try to improve their health in some way. And a lot of that comes from the weight loss that people experience. And when you artificially or make sure that the people don't lose weight, or you try to make sure that they don't lose weight, it's a little difficult to then apply that to the real world, since usually when people are restricted to only consuming food within 1 to 2 hours, then usually they're going to end up losing weight, especially if they're going from a standard unrestricted diet to suddenly restricting their time window, which of course limits the amount of food that they can consume. Of course, it depends on what food they're consuming during that time, but in general, you can start to really lose some weight. And it was intriguing because a number of years ago I had released this video looking at one of these studies, and the conclusion ultimately from the results was that OMAD, or 1 meal a day, led to slight insulin insensitivity. And that's because when they compared the OMAD group versus the 3 meals a day group of individuals, the diets were the same. So nothing special. It wasn't keto or low carb or vegetarian or anything like that. The diets were the same, however. And ultimately, they did an oral glucose tolerance test to test the insulin sensitivity, and they found that insulin sensitivity was worse in the OMAD group. Now, part of that may have been because of the timing of when they did the oral glucose tolerance test, because if you do OMAD late at night, that means you're backloading all of your nutrients, all of your food consumption, especially if you're trying to maintain your weight. You have to, let's say if you maintain weight at 2,500 calories, then that means you have to eat 2,500 calories in one meal at the very end of the day. That's a huge burden of nutrients at the very end of the day. On the other hand, for the 3 meals a day, if they consume the same amount, they can spread it out over 3 days or over 3 meals, which ultimately leads them to be able to split that across those 3 meals. So you're not consuming nearly as much in the evening as you are with the OMAD group. So it's possible that the benefits of OMAD were during that period of fasting, and then because they backload all those nutrients at the end of the day, that could translate to, if they're measured, the blood glucose levels and the insulin levels are measured in the morning of the very next day, that could lead to some problems, because then they may still be processing a lot of those nutrients. As opposed to a 3 meals a day condition, they've already front-loaded some of their nutrients the previous day. So they've been processing those nutrients, and they only had to process 1/3 of the amount of food. So that could throw off the study. So I think that was a really fair critique. And unfortunately, for that study, when I released the study analysis for that, which again was a number of years ago, people were really upset with me, because they were like, well, that's not my experience, it's BS. The usual stuff where people take their personal experience and apply it to the study and then don't contextualize things. So again, I had to repeat, well, did you lose weight? If you lost weight, then you already don't belong in this study. Like, the results here don't apply to you, because we're talking about weight maintenance OMAD, which again is pretty artificial. So ultimately, I wanted to correct that. So I looked at a number of different studies. I tried to pull together as many studies as I could. There aren't that many, really. There are plenty of studies on intermittent fasting, like 16-8, or 18-6 or whatever, but there are very few studies that look at 1 meal a day specifically. And so I was able to pull together 3 or 4 studies, 3 studies specifically on OMAD, and then 1 study that was a 4-hour eating window. And I just threw it in there, even though you may not believe that it's actually would be considered OMAD. And the data ended up corroborating what I said, actually. So the studies that the people maintain their weight, they tended to have higher blood sugar levels, regardless of when the tests were taken, if that was in the morning or if that was in the afternoon. There was another study that did in the afternoon, and they found the same results, that there were elevated blood sugar levels. Not saying that it was unsafe, not saying that it was like diabetic or anything like that, but it was elevated compared to the 3 meals a day. Now, some other metrics that were also changed were like blood pressure. I think blood pressure was a little bit higher. However, here is where, like, again, that nuance comes in, because the way the statistics were done, they didn't actually compare it to they didn't compare the 3 meals a day versus the 1 meal a day. They actually compared, or I guess they did do that, excuse me. They did compare between those two, but what they failed to consider was the baseline measures. So how much change was there from baseline? And the reality was that the baseline measures were the same as the 1 meal a day. So the real interpretation of that is not that 1 meal a day is worse, like leads to increased blood pressure, which if you just compare the 3 meals a day and you see that that is lower than the 1 meal a day, you think the 1 meal a day then has higher blood pressure and therefore it increases blood pressure. That's not the correct interpretation, however. The correct interpretation was that because baseline values and 1 meal a day values, so baseline meaning that like 4 weeks prior before they started 1 meal a day or 8 weeks prior before they started 1 meal a day, they had blood pressure measured, they were the same compared to the 1 meal a day. And they were lower in the 3 meals a day. So the real interpretation should be that 3 meals a day was beneficial towards blood pressure, that it reduced blood pressure slightly compared to baseline or compared to the 1 meal a day. However, that's not against the 1 meal a day. Okay, so those are some interpretations. Those are some things. It wasn't, but ultimately, then there was one study that looked at weight loss with 1 meal a day, and they found reduced blood sugar, improved insulin resistance. They saw either no effect or maybe a slight reduction in blood pressure. So I think it really just matters on how you use 1 meal a day. And I've said this many times before, if you're doing weight maintenance with OMAD, maybe there may be some very minor drawbacks of it. But again, this may also matter because of the timing of day. So if you do OMAD in the evening as opposed to in the morning, I know some people have reported that in the morning may be better than in the evening. I haven't looked at that in any level of granularity because, again, I don't know what studies they're really referring to. A lot of the studies don't distinguish very well between them. So I think in general, that's another area where I have to say that we need a lot more data. But as it currently stands, I would say that, if you use 1 meal a day, and even if you try to maintain your weight, it's not like it's going to lead you into diabetes or anything like that, no matter when you do it. I think it's perfectly fine to do. There may be some slight disadvantages in terms of like blood sugar or insulin sensitivity just by a very marginal amount, and blood pressure possibly. Not that it's going to increase it, but what benefits you might see from spreading out the meals, that may be eliminated. And if you lose weight on OMAD, which is what most people do, then it's a net benefit. Overall, it's just a benefit. So if you use OMAD for weight loss, then it seems like it's probably pretty good. Only 1 or 2 studies on that, though, so probably need more data on it, but I feel relatively confident. I don't foresee any sort of scary alternative conclusions coming out of more data. So that was my take on OMAD. The next one is to discuss fiber. So I released a video, actually real quick, coffee break. So I released this video that looked at Dr. Paul Mason, who is a kind of carnivore keto doctor, or seems to espouse that kind of mentality a lot more than anything else. And he had this interview that he gave, and he's given presentations on this as well, but essentially talking about fiber and why we don't need to be consuming fiber. And he cites this particular study that, again, I'd covered for the Physionic Insiders, and then it popped up again, so I decided to cover it publicly as well. And the study essentially took people that were experiencing significant stomach discomfort and colon discomfort, and they were consuming, I believe they were already consuming a really high fiber diet. And the researchers had some people stay on the high fiber diet, some people lowered their fiber intake, and then some people just cut out fiber entirely. And the people that cut out fiber entirely were able to alleviate all of their stomach discomfort, colon discomfort, constipation, all that stuff. All of it disappeared, which is pretty impressive. But the study design was, again, horrendous. They didn't report the amount of fiber. They didn't report anything else. They didn't even report the amount of fiber that they were consuming before the study began. They didn't there were they also reported data in a more of a like a strange way. It was just like percentage of people that experienced relief, but it wasn't like very numerical in terms of like being able to determine like a standard error of the mean, a standard deviation, things like that. It was just like these people experience benefit. It's like, okay, well, how did you really measure that? And is there a way that I could look at the data for myself and try to determine how close they are to feeling relief versus no relief, or how much relief, and things like that. Like, there are a lot of issues. But no matter what, like if you eliminate fiber, the answer is it's zero fiber. So clearly they experienced benefit. So, then that was his argument for why we shouldn't consume fiber. And then he said that there were no other studies that show, I think, if I remember correctly, that there are no other studies that show benefit of fiber. And that really knocked me out my socks, because I thought, well, that's just nonsense. And sure enough, it was so easy for me to find like 30 studies on fiber that all showed benefits with very little heterogeneity. There are multiple meta-analyses. Meta-analyses are another area that people seem to fire back at me, because it seems very clear to me they have no earthly idea how a meta-analysis is performed. And a lot of people commented, well, these aren't randomized controlled trials that I cited in this video, and which was, again, complete nonsense. Almost all the studies that I referenced were randomized controlled trials. Again, it just goes to show that people just don't critically think, and some people, of course, I'm not talking about most people, but some people don't critically think, and they also just they just want to believe what they want to believe, which is fair, but you don't belong here. That is simple as that. You don't belong in the physionic world. So ultimately, I found a number of different studies that showed the benefits of fiber, and across all the metrics that Dr. Mason had mentioned. So like constipation was the major one. So, and the ability to just use the restroom, and fecal bulk, and like all kinds of different other metrics that may not be that appetizing to you if you're eating right now, or if you're drinking something. So, but the point was that overall fiber had a number of different benefits. And while the video is largely focused on the ability to relieve constipation, I also understand that I also received a lot of comments saying, well, I eliminated fiber and I experienced significant benefits and significant relief in my constipation symptoms and all that. And I'm not going to dismiss that by any means. And I also don't dismiss the study that was cited by Dr. Mason. I believe the results. I believe the results. Even though the study is pretty crap, it's just done very badly. How do we reconcile that? Well, I think that just like anything, nuance. It comes down to, there may be a subpopulation, a subgroup of individuals that if they consume too high a fiber, or even a little bit of fiber, that their body just doesn't react very well to it, and they experience significant benefits from eliminating fiber. Like to have that many people just eliminate fiber, even in an uncontrolled setting. So maybe we might get more of that in a more controlled setting, and in future studies, which I hope that we get. There might be some people that experience negatives from fiber consumption, and they feel bloated, and they feel constipated, and they feel just in general just like crap. So for those individuals, maybe it might be beneficial to cut out fiber entirely, or to lower your fiber intake. The only drawback, one of the major drawbacks, I suppose I should say, for that is that fiber obviously shouldn't be just looked at in this insular notion of, well, it's constipation related, it's bloating related and whatnot. It has significant health benefits. I realize that, again, people seem very confused. They're like, well, we don't absorb it, so how useful can it be? It seems like a pointless molecule. And I get that, but it's pointless to your it's pointless to your eukaryotic cells. It is not pointless to the microbes that are found in your microbiome. And that's another consideration. It may be that those individuals that experience relief from lack of fiber may have a different microbiome composition. That's an area in infancy. Like the research area is so much in its infancy that we need a lot more information on the microbiome. So my stance on fiber, well, let me finish my thoughts on fiber and how it affects our health. So fiber affects our microbes in that the microbes take up the fiber. So while our eukaryotic cells, the intestinal lining cells, the epithelial cells don't take up fiber, they do, however, take up the short chain fats that are produced by the microbiome. And the microbiome produces these short chain fats, which are then fed to the epithelium, to the colon cells, for example, or the intestinal cells. And those short chain fats then can actually be delivered to things like the liver. And if that occurs, the liver seems to experience benefit from that, in that insulin sensitivity seems to improve, as one example. And it can affect a number of different other areas as well. So, and fiber by its structure as well, especially, I want to say, I'll say viscous fiber. So people think of fiber as soluble and insoluble. It's really on a spectrum. And there's also viscosity levels to fiber. Very viscous fiber can trap nutrients as well, which can also eliminate some of the absorption of those nutrients, which in certain scenarios can be a benefit, in certain scenarios is not a benefit. So in the beneficial scenarios, like if you are consuming a very greasy food, for example, and you have fiber along with that, well, some of that greasy food material may not get absorbed. That's probably a net benefit. On the other hand, the negatives would be if you're taking it with like some sort of micronutrient-rich food, that the absorption is already maybe very low, and then you consume fiber on top of that. The fiber can block the absorption of that micronutrient. So it's like everything, it's context based. It's really just about having a conversation, trying to figure out the details for you as an individual. But as a whole, in science, fiber has been shown to have a net benefit to our health. Again, these are areas that I need to have far more in-depth analyses, but there's a tremendous amount of research out there looking at the consumption of fiber, and it really does strongly indicate that it is a net benefit. Okay, so my stance overall, and at the end of the video I mentioned this, is that I think that if it really depends if you're on, let's just limit it to two sides of a coin. So on one side, you're the type of individual that if you consume fiber, you see net negative, like you start to feel really bloated, you start to feel really constipated. And then when you eliminate fiber, that you see some real benefits, like you see all those symptoms disappear. It's kind of like the carnivore diet almost. If that's the case, if that's the only thing that you change and that's what you experience, like who am I going to sit here and tell you, hey, keep taking fiber, you're going to be miserable, but you'll be healthier for it. It's like, okay, at a certain point, the immediate problems right in front of us that we are experiencing are the ones that ultimately have the most control over our lives. And those are the ones that we need to focus on first. So I get that. Do you miss out potentially on the positives of fiber, the long-term positives of fiber? Yeah. Again, it's a give and take. On the other hand, if you're the type of person on the other side of the coin, if you're the type of person that consumes a large amount of fiber and you experience betterment, I got a lot of comments telling me, yeah, I've started implementing fiber and my constipation symptoms disappeared, which is more in line with what the research says, then you're probably in that majority of individuals that, yes, you should be continuing to consume fiber. And not only do you get relief from constipation and bloating and all that, but you also get relief. You also get the benefit of the short chain fats that are produced. So Oh, and I suppose I'll address one more thing that Dr. Mason says. He says that these microbes that take up the fiber and produce these short chain fats, those short chain fats then get produced into ketones, and the real effects, the real benefits are to like insulin sensitivity, for example, because that's the only thing I can come up with off the top of my head, is that it's due to the ketones that are produced by the epithelial cells, or I guess the liver cells, I should say. I'm sorry, not the epithelial cells. The short chain fats end up at the liver. The liver then uses those to produce the ketones, and those are the benefit to insulin sensitivity and just overall health as a whole. And that is, again, nonsense, because there have been direct studies that have looked at in vitro, so looking at plating liver cells and literally plating a number of different types of cells, not just liver cells, brain cells, all kinds of other cells. And they've literally applied the short chain fats that the epithelium, or that come from the microbes, to those cells, and have found the positive effects applied directly to those cells. So it's not through an alternative mechanism. I guess I shouldn't say it's not because of that. I should say that there's direct proof that the interaction of the short chain fats without being converted to ketones leads to direct benefit. Okay, point blank. That said, that does not mean that the ketones couldn't also have a benefit. And that's I think the proper way to interpret that data. Because it's not saying that the ketones don't have a positive effect, but to say that the short chain fats, that all the positive effects are because of the ketones, is nonsense to me, because there's direct evidence where there's nothing else that could be going on. When you're looking at a plate of cells and you're applying something to those cells, there's nothing else that could be going on. It is because of that direct molecule that you have applied that is leading to the changes in the cells. So in vitro research can be really useful in that context. So yeah, that's my stance on fiber. I think that as it stands currently, and I'll be doing future investigations, more in-depth investigations into this, because there's all kinds of different types of fiber too. The overall stance is that I think if you can tolerate fiber, you should probably try to consume an adequate amount. And if you don't tolerate fiber, look, it's up to you. It's obviously up to you and your physician. Your physician's probably going to tell you to try to consume fiber, unfortunately, without necessarily thinking about the context, unless you've got a good physician, in which case, hopefully they'll hear you out and try to work with you. Or a nutritionist or a dietitian, someone who can actually help you more directly. But yeah, maybe try at least lowering your fiber intake specifically and see if that has an effect. And if you really do feel better, look, again, who am I to disagree with your personal experiences, even if it's against what the science says? I really think that it's very possible there's a subgroup that's being missed in the fiber data, where the fiber data affects 80% of individuals, but maybe 20% of individuals experience this benefit of not consuming fiber. That's entirely possible. That's almost always the case. So as is always the case, I feel bad when I say this all the time, but as is always the case, we need more data. But at least I can offer some nuance. At least I can offer, like, for the vast majority of people, yes, fiber is beneficial. And I think it's probably beneficial for everyone, but at a cost for some people of extreme discomfort. So I completely understand if you want to cut it out or lower it at least. All right. The next topic is cancer as a metabolic disease. Wow. Look, this is a really tough one. This is a really, really tough one. So I released a video, like a 19-minute video, looking at cancer as a metabolic disease, and I still expect to release a full study analysis on this as well. But this is such a tricky subject. This is such a difficult subject that I have had to hold myself back from just looking at the studies that have, so looking at the reviews that I had pulled together. So one of them is by Dr. Thomas Seyfried from Boston College, or Boston University, not Boston College, Boston University. And then there were a few other reviews looking at the metabolic side of cancer. And then there was another review that was looking at the cancers that feed off of fat as opposed to glucose. And this is such a difficult topic to discuss, and I don't feel secure in my knowledge on the topic quite yet. And the reason why I say that is because I need to be really careful, and I think you need to be really careful listening to me on this topic, because I know a lot of information. Cancer is a beast of a disease. It's not like diabetes. It's not like Alzheimer's or sarcopenia or any of these other disease states where usually the manifestation is usually one-sided. It can happen one of just a few different ways. Cancer is such a monster that it can present itself in so many different ways. And I'm genuinely trepidatious about me talking about this topic and then misleading people, especially people that are suffering from cancer. I would feel downright horrible if I ended up being saying something really conclusive about cancer when I feel like I need to, or I think I need to do a lot more research on the topic, or analyze a lot more research on the topic, and not necessarily scientific reviews, but actually look at primary data. So actually look at those studies for themselves. And the reason why I say that is because cancer comes in so many different forms. Like, if you were to look at breast cancer, for example, or prostate cancer, or osteosarcoma, or if you were to look at brain cancer, glioblastoma, or, it's just so many prostate cancer, ovarian cancer, it just happens. It's so all over the place. Colon cancer. And people think that cancer is cancer. But that's so. I know that is wildly inaccurate. Wildly inaccurate. Cancer is not just cancer. It's just like diabetes. Just do this and done. It's such a treacherous disease because even within so you have cancer, and then you have the umbrella that branches out to all these different areas of cancer. We're just talking about the areas of cancer. Then we have within each area of cancer, we have the different mutations and let's call them types of cancers. So BRCA mutation, or you have a HER2 positive mutation, or triple negative mutation, or triple positive mutation. It's so overwhelming. So for one video to just release and say, well, this is what you need to do, or this is what cancer's like. It's that is, I think, to me, that is so irresponsible. And I have to be really delicate about this. So I hope you're getting a sense here that I'm being cautious because I shouldn't be speaking out of my rear end when other people seem to. I've gotten a lot of emails from people asking me to help them, consultations and whatnot. I've just said no to all of them because I need to be I just need to be as honest as I possibly can be. And while I do have the tool set, I have the education to be able to look at a cancer and break it down and understand what works, what doesn't work. The problem is that I have to do that for every single subtype of the subtype of cancer. And there are literally thousands of studies on these different subtypes. So it is such an overwhelming amount of information that me reading 3 or 4 reviews, and again, I still plan on releasing this study analysis, but I will definitely be putting a disclaimer on it, that me reading 3 or 4 study analyses is just, it's going to be the surface level of, it's like skimming the very molecules of surface level above an ocean of information. Like, that's what it feels like. And for me to not communicate that really directly, the uncertainty that I have, and the uncertainty that I think so many people should have, except for cancer researchers themselves who dedicate their lives to a particular subtype of cancer. Yeah, I think it's a responsibility on my end. And that's why I know a few people have asked me about, like, when is this study analysis coming out? I get this question all the time. What cancers are susceptible to fat? Which cancers are susceptible to glucose or carbohydrates or sugar? And I simply can't, like, I can answer that, but is it going to do justice? Like, is that going to apply to every single individual circumstance? It depends on the progression of the cancer, where it's located, the subtype. Like, it's just, there's so much. I'll stop disclaimering this, but I just want to be very clear that this is a topic that really requires a lot of information. And the video that I released, I'm still very proud of it. I still am very happy that I did it, because I specifically didn't go into any details on the types of, like, you should do this. I probably won't anytime soon. The overall point of the video, Cancer is a Metabolic Disease, is to discuss this idea, this hypothesis that's been brought forward by a researcher by the name of Dr. Thomas Seyfried. Or maybe, I don't even know if it was brought forward. I think it was. It's also called the mitochondrial metabolic theory or something along those lines, MMT, versus the opposing, or the more commonly appreciated, more commonly thought of type of understanding around cancer is a genetic-based disease where you experience specific mutations, and those mutations ultimately lead to cancer progression. That's such a really basic, rudimentary understanding of it. And that's what I was taught in my PhD. And I had many, many lectures on that. And I've taken courses on cancer specifically, and looking at cell signaling within cancer. And there's a lot of great evidence to indicate that is at the very least, a factor. And that's really what I tried to get across in the video, that the mutation, or the genetic basis for cancer does have a lot of merit behind it. However, this metabolic idea also seems to have some merit behind it. And to ignore that completely seems like an injustice to what could potentially be a great therapy. So unfortunately, I think people are looking at things as this really simplistic, like, oh, well, if I just cut out carbohydrates, and if I just stick to a ketogenic diet, or if I just fast, then I'll increase my blood fat levels, and therefore my body will rely exclusively on fat, reduce glucose levels, and therefore I'll be able to fight off every cancer known to man. And that is just a wild oversimplification There is some research that indicates that like certain cancers, and this is why I'm being broad about this, but certain cancers are more susceptible to to ketones or high fat, like different fatty acids, like different molecules of fat. So if that's in ketone form, or if that's in the actual structure, the actual fat molecule itself. So some cancers have real difficulty growing and continuing to proliferate. That's the term for production of new cancer cells when they are in this type of environment. So that's great, but does that mean that all cancers need to have this reduced blood sugar circumstance to be able to fight it, to fight off that cancer? The answer is most likely no. And there have been some studies, not nearly as many as far as I can tell. There have been some studies that have investigated that. And so far, and this is real big, just like bold, so far, I have found a few studies that have shown that some cancer cells seem to be more willing or can seem to thrive in a high-fat environment. And that's where that's one of the distinctions that needs to be made, because then that means that, yes, okay, now we need to know, well, what type of cancers do thrive in that type of environment. And that's where that granularity that, one, I don't think there's enough data on the topic, but two, it's really delicate when the very foundation, the genetic versus the metabolic disease aspect of cancer is being called into question. So the metabolic disease, the MMT model, is arguing that the genetic disease aspect is downstream essentially of the metabolic component. And the argument is that, as I understand it currently, is that mitochondria inside of cancer cells are dysfunctional in some form, some fashion. And because of that dysfunction, they rely heavily on glucose. So that's the Warburg effect, where you have cancer cells that take up a large amount of glucose, of sugar, out of the bloodstream, and then use a process known as glycolysis to essentially generate energy. But not only just to generate energy, from some of the other reviews that I've read, also to produce biomolecules, so molecules that can be used for the synthesis of new cells. So it's this really inefficient pathway, but it's okay if it's inefficient because there's just such a high amount of the glucose. So it can just the cancer cell can just keep sucking up glucose and keep generating this energy independent of the mitochondria. Or that was the belief. I think that the MMT model argues that while, yes, there is some level of mitochondrial dysfunction, there are certain aspects, certain areas of the mitochondria that can still generate or help in the generation of energy. And that's where we start getting into glutamine. That's where we start getting into substrate level phosphorylation, which I'm not going to go into those right now because they are areas that I need to educate myself further on. I understand them to a degree, but they're areas I need to educate myself further on. So substrate level phosphorylation, just in brief, is it can happen in glycolysis or it can happen in the mitochondria. And that's where some of the arguments are. So the overarching idea is that because there's this common issue with cancer cells, that maybe we can take advantage of this common issue in cancer cells. And if we reduce the amount of glucose that's in the bloodstream by eliminating carbohydrates, so putting our body in a ketogenic state, in ketosis, and on top of that targeting glutamine, that then we can dramatically affect the cancer cells. And these are areas where I need to look more into those topics. But as it stands, I did find some aspects of the metabolic theory really compelling. Like there was this experiment called the Cybrid experiments, where they had two cells, One cell was non-cancerous. It was a healthy cell, and the other cell was cancerous. And what they did is they took the nucleus of the cancerous cell and the nucleus of the healthy cell and switched them so that the healthy cell's nucleus was now in the cancerous cell. And the idea here being that if it's a mutation driven, so if it's genetically driven, then the mutations that have occurred in the cancer cell will then drive the healthy cell to suddenly become cancerous, right? And that makes some good sense. However, what they found is that it had no effect. So the healthy cell was still healthy, and it was not affected by these mutations. However, when they take the mitochondria out of the cancerous cell and put it into the healthy cell starts to display some expression, some like showing a little bit like a cancer cell, becomes a little bit more cancer-like, we'll call it that. And when they take the healthy mitochondria out of the healthy cells into the cancer cells, the cancer cells become less cancerous. So that's really compelling evidence there that there's something to be said about this mitochondrial hypothesis. However, it doesn't really address some of the additional areas related to the genetic model, because the genetic model isn't just saying, oh, well, it's just mutation driven. They're also including like epigenetics, which are not mutation driven. Those aren't necessarily like, oh, you're getting a damage to a gene that ultimately leads to the production of a damaged or dysfunctional or aberrant enzyme. But you could have an intact gene, perfectly healthy gene, but the epigenetic regulation of that gene may be changed so that maybe it's repressed, so you don't get the expression of that gene. So you essentially don't get the expression of that gene, or you get more of the expression of a particular gene, which ultimately leads to imbalances in the amounts of particular proteins. One of these signaling proteins would be something like P53, which is super common in a lot of cancers. And because of that gene, because of that protein, P53 holds off a lot of pro-growth other genes. So it essentially stops the overgrowth of cells. And in a lot of cancers, many cancers, but not all cancers, P53 is mutated or inactive or just somehow downregulated so that it can't function. So that seems to be, for a lot of cancers, a prerequisite that P53 is reduced. However, again, I just have to keep repeating this. I've said this like 2 or 3 times now. Not in all cancers. So it doesn't have complete what's known as penetrance. So some cancers don't have to have that, and they can become cancerous through other means. So there's a lot of crosstalk, and it's one area where if you were to replace, let's say like the nucleus, for example, or if you were to replace the mitochondria, one area that I would find especially interesting would be to look at the epigenetic changes that occur, so that maybe that is the reason and not because of the actual mitochondria. That's, I think, even in my mind, that's a little bit of a stretch, but it's still something that needs to be addressed. Before I just like jump ship and just, well, I don't even know if I would jump ship, because there's plenty of evidence that if you cause certain mutations to the genome, like very specific mutations exactly where we want them, that we can cause cells that were perfectly healthy to suddenly become cancerous. So we know that there's a genetic component. There's for sure a genetic component, but it's really the chicken and the egg. Which one came first? Is it, at least from the mitochondrial metabolic theory or perspective? I think they're claiming that because there's this dysfunction of mitochondria, that ultimately downstream leads to issues in the genes, and that then leads to this progression of cancer. However, the genetic model would say that it's the genes come first, and it may not even be necessary to have dysfunctional mitochondria. as I understand it currently. So I'll be, of course, making updates as I learn more. But I still wanted to address it. I I mainly wanted to address. I just mainly wanted to communicate my trepidation about the topic, and I guess I'll announce it now. I've actually been speaking to somebody in Doctor. Wow, I forgot his name. Well, I've been speaking to somebody in the lab of the person that I mentioned earlier that for some reason is now completely evading my memory. Isn't that funny how memory works? And so this person that's at Boston University, and there's this person in the lab that reached out to me, and we've been communicating back and forth, and we're hopefully I need some time because I've got a lot of things going on over the next month and a half. But I'm hoping to have an opportunity to sit down with Seyfried. That's the name, Dr. Seyfried. So I'm hoping to sit down with at least that person, and which would be a real honor, and potentially with Dr. Seyfried as well, and potentially both of them, in a kind of a long form conversation to discuss, and for me to be able to ask some of these questions related to the metabolic theory. I think before that, I'd like to read some of the genetic models and understand that a little bit more, so that I can come with some more poignant questions. Because I'm really just trying to learn more. And to be completely honest, the ideal scenario would be somebody that's more knowledgeable than I am to be on the opposite side. Somebody that's in the genetic, that knows about the genetic aspects and believes in the genetic aspects a lot more. But man, oh man, what a, again, the other thing is I don't want this to be a debate. It's such a weird thing for me to say, but I just believe in like having discussion, like trying to like, okay, what do you think about this piece of data? And it's not like pitting study versus study. It's like, okay, let's open a study and let's break it down. And are we in agreement in how we interpret the data here? And then let's move on to the next study. Are we in agreement how we interpret this data? Oh, okay, you believe. And it's just like, it's a lot more civil. It's a lot more discussion based because, and that's really difficult when you're talking about people that have dedicated their lives to a particular topic. I'm not saying that researchers can't try to be as unbiased as possible. They do try, but they can be pretty passionate individuals. They're real nerds. they really care about what they've been studying, which I don't blame them. But it's always kind of weird for me to say like, oh, the debate, the showdown between metabolic versus genetic, it's like, then it becomes more of like who can win as opposed to, it's almost like kumbaya. It's like, why shouldn't we all win by just having a discussion? Essentially, I would really much prefer to have a discussion and for me to be wrong or corrected on certain aspects. And then for me to, for me to hear both sides as opposed to just having this like end goal of like one side pitted against the other for who will win the prize. That doesn't, I just don't think that really, it might be entertaining, it might be exciting, but I don't think it would be that helpful. Unfortunately, I think it would still lead to like half the people saying, oh, I believe the genetic model, half the people saying, I believe the metabolic model, but it would still create this fissure between both sides. And it doesn't start to create some of the tendrils reaching across and kind of shaking hands with the other side, like the two hemispheres of the brain communicating with one another across the corpus callosum. Anyway, so yeah, I'm hoping that I can talk with Dr. Seyfried, and that would be really great. No promises. It really very much depends on my workload, and because I'm really handling a lot right now. I'm working at max capacity all the time. So I would certainly welcome the conversation. It would be super, super interesting, and I'd be absolutely honored to do it. And maybe if the time comes along, I may ask for some questions, but I really need to make sure that I make the best possible time. Like I take advantage of the time as much as possible so that I can ask questions that are going to get to the crux of the issue, to the, not just like, oh, what kind of diet should I follow? It's like, yes, that would help maybe that individual, but I think ultimately we need to start bridging the gap between both sides and really try to get to some sort of conclusion that can help us take a step forward that's going to help everyone, not just a single person. So yeah, that's kind of where I stand. I realize that doesn't really offer many answers, and that's kind of where I want things, honestly, for anybody listening to this. I wish I could offer you like definitive answers on this topic like I can with certain other topics like LDL, for example, or ApoB. But I can't, and I think that's the right stance to have at the moment. And hopefully in the future, who knows, maybe it'll be 5 years, maybe it'll be a year, maybe it'll be a few months, I don't know. But I hope that as I learn more and I become more and more concrete and understand, the trends in cancer research specifically, that I'll be able to offer a lot more information. I do still plan on doing a part 2 for the cancer as a metabolic disease. I failed to emphasize substrate level phosphorylation and the glutamine issue. So I would like to do justice to that and have a part 2 for that video. And obviously, if I end up having the pleasure of talking with Dr. Seyfried, then I would love to incorporate some aspects in maybe like a part 2 or part 3 of the cancer video. But I think there's a lot of stuff that I need to reconcile in my head. And it's not because of my formal education. It's literally because I've seen studies that show good evidence for the genetic model, but I also don't want to ignore some of the great evidence for the metabolic model. And that's why at the end of the video I said, well, isn't it possible that they could both be correct in some way? Like that they could be hand in hand, that for certain cancers they may be more a genetic component, like it starts off as more of a genetic component, and other cancers maybe it's genetic, but yes, there's like the way to treat it would be through metabolic means. And keep in mind, this is a person who's been dedicating, like most of my research has been in metabolism. So, I'd love to jump ship and just be, not that I should pick sides, but like I'd love to be able to say, yeah, it's a metabolic disease. I have to follow the evidence, and the evidence just doesn't indicate to me currently that it's foolproof. Oh yes, it's absolutely a metabolic disease. Okay, I'll stop bloviating on about the topic. I did want to cover one more topic, and then I'm going to go into a Q&A, and then I'm going to tell you a few stories actually from people that have written in, and people that have written comments. So I thought I'd share, because not only are the stories relevant, but they actually have some additional information that might be of use, some actual application for you. So the next topic to discuss is fasting and inflammation. Okay, so late coffee break. That coffee is still warm. Just as an endorsement to my dad's mug, it is still nice and warm, and I've been recording for, I guess, almost 2.5 hours. Okay, so the next topic is fasting and inflammation, and this is another topic that I had released a video a number of years ago, I think maybe in like 2020, where I had released this video that had this inflammatory title, pun sort of intended there. Fasting increases inflammation. It had me being super serious on the thumbnail. And the thing is that was not clickbait at all. The video was literally about exactly that, and it showed proof that there was an increase in inflammation from fasting. And I realized that for a lot of people that undergo fasting and they see their inflammatory markers decrease, or they feel better, they lose weight, all these different things, blood sugar gets better, triglycerides get better, cholesterol gets, like all these different metrics get better. you look at that and you're like, oh, whatever. Like, you're so full of it. Forget this study. They must have missed something, or like you're a clickbait artist, or you're an idiot, or whatever. Totally get that. But that said, the study did show, by multiple markers, that there was an increase in inflammation when people underwent water fasting. So they underwent water fasting for 10, was it 10 days? I think it was 10 days, either 7 or 10 days. And the researchers showed that there was an increase in particular inflammatory cytokines. So these are molecules that communicate with immune cells, and those immune cells then get activated or deactivated based on which cytokines are interacting with them. And they found that most of the cytokines were pro-inflammatory, like interleukin 6, for example, or TNF alpha, tumor necrosis factor alpha. And that was really fascinating to me. But there was an additional component to this that people often just ignored, and that was that the inflammation was a positive thing. It was a good thing that these people were experiencing a level of inflammation. People like to use the word hormesis, so the a little bit of negative leads to a stronger overall body. And I guess you could characterize it that way. I don't know if I'd necessarily characterize it that way, but what the researchers showed is that the fat tissue, when these people were losing significant amounts of body fat, which they were doing, even though their inflammatory markers were increasing, their fat tissue was suddenly starting to be infiltrated by monocytes, which are a type of immune cell. And these monocytes, which eventually turn into macrophages, which are part of the innate immune system. So these immune cells just kind of scavenge around and they look for potential problems. And the fat tissue of these individuals was suddenly infiltrated with macrophages that then they showed that these macrophages had lipid droplets, which was a really cool discovery. I mean, I know it's not going to be breaking science or anything like that, but to me, I thought it was super cool. I thought for people who fast, this would be fascinating information. So I released this video. The video did very well, which is great, but people were very angry with me because they didn't understand what I was saying in the video, which may have been my fault because I didn't communicate it correctly. But overall, then I decided several years later, I stumbled across this paper that I believe just released, and they were looking at the relationship between immune cells and adipocytes, or these fat cells. And they sort of took things one step further and maybe offering a potential explanation for why the immune cells infiltrate into the fat cells, into the fat tissue. And so I decided to release a video that essentially just doubled down on what I said in the previous video, hopefully explaining things better. The comments were far more positive and far more intrigued as opposed to angry. So maybe I did a better job communicating that time, because I literally said the exact same thing because the data had not changed. And the second study essentially showed that macrophages can take up lipids. They can take up fats that are delivered by the fat tissue. So the fat tissue is filled with these adipocytes, these fat cells that contain a tremendous amount, like a huge amount of fat molecules. And there's these storage depots. I mean, they do much more than that, but for this, they're storage depots. So people would undergo fasting, and then they would see this mass release of these fat molecules. Now, the fat molecules obviously have to be packaged up into, let's say, triglycerides, and those triglycerides then have to be transported. So that's all fair. That's fine. But what I was positing, my hypothesis was that the macrophages were infiltrating into the fat tissue because they were helping break down the fat. So the fat tissue, the cells were literally packaging up large quantities of these fat molecules into these lipid droplets, these sacks of fat, and just ejecting them out of the fat cells. And then that was being taken up by the immune cells, and then the immune cells were undergoing autophagy, or really the proper term is lipophagy, where they would degrade the vesicle, they would degrade the sac of fat. And I don't know actually what happens after. There's no proof after that. But my intuition is that they're undergoing autophagy or lipophagy and then oxidizing the fats or breaking down the fats for energy, or somehow breaking them down to be released back out into circulation. So the immune cells are infiltrating into the fat tissue that is just ejecting just huge amounts of fat, and it cannot release fat fast enough through its canonical mechanism, through its normal just repackaging fatty acids, these fat molecules, into triglycerides and then sending them out into the bloodstream. Instead, not just doing that at a maximal level, but they've also just packaging them into these mass vesicles and having the immune system help in that process. And that's why the immune system is there. This is a lot of me stretching. Some of this is purely me guessing. And the second study was in obese individuals. It was not in fasting individuals, but they still showed the same event happen where the macrophages were going into the fat tissue. Now, part of that may be because of a pro-inflammatory response that is negative, because we have higher levels of inflammation, chronic inflammation in obese individuals, which is all fair and good. But in fasting individuals, it may lead to the same event, but in the fasting individuals, it may be a more transient event. So there's an increase in inflammation that is specific to that site, and then it reduces once the fast is over, or it equilibrates somehow. I don't know. But the event was the same, where the immune cells were taking up this fat in these fat vesicles, and something was happening to them related to autophagy. And that's point blank. That's where it stopped. I'm adding this element of maybe the immune cells are helping. That is pure educated speculation. So I thought it was such a cool phenomenon, and I thought I'd share just because I thought it was so freaking cool that it's possible that the fat cells, when we water fast, we are literally going at the fastest speed. We cannot lose fat faster than that, other than maybe if you take like a bunch of thermogenics or whatever it might be. And if that's the case, then it would be such a cool mechanism to have these immune cells, your immune system coming in to the rescue and helping your body get rid of this fat. How freaking cool is that? I mean, wow. Okay. Q&A. We have a number of questions. I took these mostly from one or two videos, and they're related to GlyNac, creatine, what else? Bone growth, taurine, and then I'll get into the stories. So the first question comes from Kakako Kikiki, KKKOKKKI. Am I safe taking creatine 5 grams daily and not losing my hair? Okay, so this is a topic that I have looked into way back in like 2018. And this is there's a significant amount of uncertainty around this. So there are some pretty definitive answers in one regard, and then there's some uncertainty in another regard. So the loss of hair from creatine is proposed to be through a mechanism of DHT, so dihydrotestosterone. So the idea being that if you have high levels of dihydrotestosterone, then that reaches the scalp, and then the cells there take up this dihydrotestosterone, and they use or maybe they produce high levels of DHT. Maybe that's it. This has been obviously like 6 years since I've looked at this, but I do remember it had a lot to do with this enzyme called 5A reductase 2, I want to say, but 5A reductase. So this enzyme ultimately, I think it enacts its role on DHT, or it produces DHT. I can't remember which, but it's somehow heavily involved with DHT. And there's a particular type of this enzyme in your scalp compared to in your face. So around where, for men, where your beard would come in. And there's different versions. They're called isoforms. So different versions of the same enzyme. So the structure is just slightly different. And the idea being that if you have high levels of DHT, this is a high activity of the 5-alpha reductase that's in your scalp, which ultimately then leads to a diminution. I believe DHT then further leads to a diminution in the focal region in the scalp of the hair follicles. So the hair follicles per cycle, because the hair follicles cycle over time. So it's not like you're constantly producing hair follicles. They're being produced. I don't remember the exact time frame, but let's say every month or something like that, you have new hair follicles that get produced. And I'm hoping I'm remembering all the details of this correctly. It's roughly correct. There may be a few nuances there I'm missing. And this DHT then leads to a diminution of the hair follicles that ultimately leads to the balding in the hair. So that's called androgenic alopecia. However, the idea with creatine being involved in this is that creatine seems to increase. Came from one study. I believe it's one study in rugby players. And again, I haven't gone over this in 5 years or 6 years. So this study showed that people who took creatine saw a significant rise in DHT levels. And therefore, it was a potential risk because of this mechanism with DHT in the scalp, that you would see a diminution of the hair. However, the problem is that and the certainty, this is the part that's certain, is that it very much depends on your genetics, on which version of the 5-alpha reductase enzyme that gets produced. So some people have very low levels. I'll bet you if you were to test me, I would have very low levels of this particular isoform of this 5-alpha reductase, because I'm not going to be balding anytime soon. And you can know that, or you can have some good indication of that based off of the family history of balding. If no one in your family has a history of balding, especially on, I believe, your mother's side, then you are unlikely to be affected. Even if creatine increases DHT, you are unlikely to have a negative effect in terms of balding from creatine. If you do have a family history, the jury is still out. I will say there is a study that is currently being performed. I believe I remember reading this 3 or 4 months ago. I was looking through the clinical trials and I just stumbled across this paper that specifically, I think they were specifically looking at the effect that creatine has on balding and androgenic alopecia. So we'll get definitive answers, I hope soon. Maybe it'll be a few more years, I don't know. But as it stands, the mechanism is a little wonky. And I don't know if it's absolutely, or I know that it's not absolutely certain that creatine does lead to diminution of the hair or anything like that. It's just through this mechanism. And as we know, focusing on just a mechanism without any outcome data is really dicey. So I would, on the safe side, I would maybe avoid creatine for that reason. If you're really paranoid about, all it's going to do is speed up the process. It's not like if you stop taking creatine, you're suddenly your hair is going to come back or anything like that. So, there's it really, the way I would interpret it is to look at your family history. And if you don't have family history, I wouldn't worry about it. If you do have a family history, I would worry about it. And then it's a judgment call up to you, where you can decide if you want to take creatine or not take creatine and see if it has an effect on balding. But the real answer is that we don't know as of yet, but hopefully very soon we will. Okay, so the next question is no problem too big 337. I was wondering why you had no mention of Glynac, especially after your video speaking so highly about these two amino acids when combined. So Glynac, if I mentioned this in the past podcast episode in detail, that's glycine and N-acetylcysteine. The combination of the two leads to the production of glutathione. So Glynac supplementation is thought to, through glutathione production, lead to a host of different health benefits. And so there were a few studies coming out of one research group that from University of Baylor Medicine, and I had mentioned that I want to see more data to corroborate a lot of this stuff, but they were human trials, so they had a pilot study and then they did a full study, and they found the same results. So they found really consistent results that there were better mitochondrial health, better fat oxidation or fat utilization, better insulin sensitivity, all these different metrics. I don't think it had much of an effect on cholesterol, if I remember correctly. But the point is that there were a host of different ways and strength metrics, or a host of different ways that Glynac supplementation seemed to help. So no problem too big is asking, why don't I take Glynac? And that was under a short that I released on just on 3 supplements that I take. To be clear, I wasn't saying that I only take these 3 supplements, but just real quick, the 3 supplements were creatine, collagen, and omega-3s. Those were 3 of the ones that I definitively take. I think I take some others, but I can't think of them off the top of my head. They're usually just like in a routine for me. Or was it collagen? Yeah, I guess it was. Yes, it was collagen. So then the question is, well, why wouldn't I also take Glynac if it has such positive effects after I've been speaking glowingly through these study analyses? And the answer is because of another video that I released, which was a short, where I specifically answered a version of this question. And that's because the researchers also gave Glynac to younger individuals just for 2 weeks, and they found 0 effect. Why? Well, that's because younger individuals already have topped up levels of glutathione. So increasing your glutathione levels when they can't be increased is just a waste of money. I'd just be wasting my money if I were supplementing with Glynac. So at my age, and this is the short that I released, I said, at what age or should you be supplementing if you're a younger individual in your 20s and 30s? The answer is, I say no, pretty definitively no. Even though they only did it for 2 weeks, I just don't think that you're going to see any boost in glutathione. Maybe down the line, we'll get some research to indicate that I may be wrong, but no matter what, the effect size on that is going to be really small. So it's probably better just to save your money and not worry about glycine and N-acetylcysteine supplementation, specifically for that age group. Once you get into your 40s and definitely into your 50s and beyond, that's when it starts to really become a lot more helpful. Again, assuming that the results of these studies are corroborated by other groups. Do you cycle creatine monohydrate? This is from Any Mouse 6202. Do you cycle off creatine monohydrate? No, I do not. I take it straight, continuously, forever, and I've been taking it for 14, 15 years straight. Yet another ordinary guy. I said, looking forward to the in-depth video that was on the 3 supplements, because I had mentioned I'm going to be doing an in-depth video on creatine. I have a book on creatine, but I don't publicize it because I don't really care that much about it. it's a good book. Like, I put a lot of work into it. It has over 100 references. It's all specifically on creatine, but I just don't talk about creatine that much, so I never mention it. So anyway, but I'm doing an analysis on creatine on the brain, the effect that it has on memory, if I remember correctly. So that's in the works. I can't. I'm telling you, I like the cancer thing. There's just so many things I'm covering at the same time, so I'm constantly reading research. So it will be coming sometime in the next month or so. Looking forward to the in-depth video. Thanks. I'm looking forward to it too. Meanwhile, I do have one question that's been troubling me. Is it all right to continue with creatine even if you aren't working out regularly? Well, obviously, I am not your physician. I'm just going to state that. So I don't know your individual circumstances, but creatine has been studied out the wazoo. There's hundreds of studies on creatine, and they have all deemed creatine to be extremely safe. And additionally, the benefits of creatine are far extend. I can definitely say this from my writing this book, is that creatine supplementation has tremendous effects across the body that extend far beyond the musculature. And the reason why I'm excited to do this analysis in creatine's effect on memory is because I suspect that creatine also has pretty significant effects on the brain, mainly because that was preliminary research that I had looked at. This is before the other analyses had come out. So I had there's this meta-analysis that has looked at creatine supplementation on memory and on the brain in general. And before that analysis came out, because I wrote my book, finished it in 2021, I had run across a number of studies on creatine, just individual studies on creatine and memory and the brain and whatnot. And there was a lot of heterogeneity. Some studies showed that there was an effect. Some studies showed there was no effect. And I ended up figuring out what the factor was. That I think I figured out what the factor was for why some studies showed there was no effect. And I'll give you the answer to that. It's one of the questions is offered. It's actually the very next question, so I'll be able to go into that a little bit more without knocking out the wind from the sails of the next question. So the answer to your question, yet another ordinary guy, is that, yeah, it's not just for working out. It has many benefits, and it's definitely something that I think, of course, assuming you get checked in by your physician without any specific health issues, that creatine is very helpful for a number of areas of your body. The next question is Orion 9K. Orion 9K, I've seen you comment a number of times. I can't always answer because I've been it's gotten to this point with Physionic where it's just thousands and thousands of comments now. So it's too much, but I have noticed. So thanks for commenting. Why would you go higher than 5 grams of creatine? And this is the factor that I had identified, that I thought that I had identified. We'll see if that actually ends up panning out in the research, but the research indicated that with creatine supplementation for the brain specifically, the brain actually has its own mechanism for producing creatine, and as weird as it sounds, shutting down that mechanism seems to potentially be a benefit to the brain, not because the brain is doing a bad job of producing creatine, but because you have to kind of outpace the amount of creatine that the brain produces. And for creatine to get across, I suspect, the blood-brain barrier, that you need really high levels of it. And that's where in this video, this short that I mentioned, I was taking 5 grams of creatine. And that's what I've been consuming for my muscles and for my bones and for all the other benefits that it offered. Also, I think for cardiovascular health as well. And immune health as well, interestingly enough. So Yeah, so I was taking 5 grams, and that's enough for basically everything under your brain. But what seems to also be beneficial is consuming a lot more, because that then can saturate the amounts that are found in the brain. So when you take, let's say, 5 grams or 3 grams or any amount of creatine, your liver stops producing nearly as much. And then I realized that the next question a lot of people are going to have is that safe? Will it's, does that mean I shouldn't be supplementing? The answer is no. The moment you stop supplementing and the blood levels drop, the liver picks back up and starts producing creatine again. So that's not an issue. I wouldn't worry about that. But what I would worry about is not consuming enough creatine for the brain. And again, this has to bear out in the research. I haven't really looked into this in any depth. This is just from preliminary studies that I looked at. And I teased out why some studies showed no effect, some studies showed an effect. I started seeing this trend based on this factor of the dosage was low in the ones that did not have an effect and was higher in the ones that did seem to have an effect. So that's why, and I don't know what that dosage is, but I'm suspecting it's far in excess of 5 grams. I'm saying at least like maybe double, maybe triple the amount. I don't know yet. And again, I could be completely off, but I think that seems to be about right. So if the research ends up indicating, yes, there is an improvement with higher doses, then I will be increasing my creatine dosage to whatever dosage they end up determining. Heiko Tio on my Taurine video. I'd like to hear more about the bone growth aspect. Could this help with osteopenia, joint rehabilitation, and dental health? Yeah, so there's some speculation on my part here, but so the question from Hycio, I don't know how to pronounce this correctly, so excuse me. Hycio is based off of the fact that the taurine supplementation study showed bone remodeling and growth with the supplementation of taurine in the mice. So over time, that they were able to preserve. I imagine it's probably the preservation of bone. Looking at their spine and I think their femur as well, so their leg. And it was pretty substantial. It was like, I don't know, like over 50% preservation of bone. So I don't know about dental health. I mean, obviously, dental is also bone, but it's possible it could have some effects. And I would posit that the research is leaning towards that direction, that it could have some positive effects for osteopenia, for example, or osteoporosis. So, I mean, is it worth a shot? Yeah, I'd say so. Again, with the same disclaimers that I'm not your physician, but if I knew somebody that was suffering from significant osteopenia or osteoporosis, I think the only drawback is like, does it actually? We don't have any proof that actually helps in the regrowth of bone. So, a lot of those conditions are actually helped by resistance training. And there, I had this short that released many months back saying you should resistance train as early as possible because that has the greatest effect at preserving your bone mass for the later in life. But if you start later, it can also have significant effects, just not as significant of effects. So would taurine potentially have an effect? Yeah, possibly. Okay, so now getting into the stories. I have 3 stories, which are actually going to be have some interesting, potentially applicable information here. So stories from Less Than Optimum. So I never entered a modern gym until I was in my 70s. I had decided to self-heal a back injury by exercising the muscles that support my spine. Good thinking. Twists and doing stuff like that, etc. When I was 81, I was doing sets of 20 pull-ups. Wow. I mean, genuinely, wow. That's absolutely incredible. That is some of the most impressive stuff I've ever seen. That's incredible. And also a lot of kettlebell exercises. Also a good way to go. Never too old. 84 now. That's, I mean, truly, that's at that age, being able to knock out 20 pull-ups. I mean, I imagine I weigh more than you do, but still, I don't know if I can knock out 20 pull-ups. I get maybe in that range, in one go, but 20 pull-ups at any age is really impressive. But at 81, that's really, really stunning. And this was under a video about resistance training. Again, you're never too old to start resistance training, and it has just such profound effects across the body that it really is something that everybody should consider doing. It doesn't have to be much. It can just be once a week, twice a week, for like even as low as 15 minutes, 20 minutes, can have really profound effects. So this is a great example. Thank you for sharing. The next one is Rui Marquez, 4369. I am 44 years old and I take taurine every day. I've been working in shifts for 18 years. Taurine is a salvation for my sleep, and as I train every day, strength and cardio, it helps a lot to do those shifts, sleeping during the day and daily physical exercise. So I guess some of this got messed up when I was recording it. So taurine being really helpful for helping with sleep, which is something that I did not know. Again, that's not something that was covered in that study. So taurine seemed to help with sleep, tended to help with training, exercise, so for strength and cardio, and tended to be overall, seemed to be a salvation in overall health. So yeah, thanks for sharing. Again, so this is, it's an anecdote. It's just a positive anecdote. It doesn't actually mean that taurine definitively has these effects. But if you pair that with the research that we've gone over so far, I would like to look at more research in humans specifically. But looking at the research so far, it does seem like this seems to be in line with a lot of that. Although sleep aspect is not something I've covered. So I'd be curious, one, as to the mechanism, but secondly, to actually look at the outcome data on that as well. So thanks for sharing, Rui Marquez. The final one is Joseph Taylor, 6285. Okay, this is a bit longer one. I've been on glycine and NAC, so that's the two ingredients I talked about earlier. So glycine and N-acetylcysteine for a month now, taking 10,000 milligrams of glycine a day in a capsule form with 1,000 milligrams of NAC before bed with my last round of glycine. So far, my nails are hard as rock, and the new growth at the base is losing those terrible ridges one gets in older age. My knees are so solid now that I can run up the subway steps without so much as a twinge of pain. My legs have an extraordinary amount of power I haven't known since my 20s. Jeez. My skin, which has been very good since I started keto 5 years ago, has a youthfulness to it that I'm still shocked to see. My eyesight has improved and I sleep all the way through the night for 7 hours. I need it for... taurine also helps with urinating a limited amount, so just a couple times a day, and I no longer need to go in the middle of the night. For your reference, my diet is nose to tail carnivore, so I guess it was keto and then transitioned to more carnivore, and I also supplement with a number of other things. But, and this is the key point, but it was when I started adding glycine and NAC that my health and energy went stellar. So felt pretty good before with keto and nose to tail carnivore, but then with the supplementation of Glynac, started to experience real benefits to health and energy. And this person is 64. So right in that range that Glynac would be really, really beneficial. So thanks for sharing. And also with the amounts and just all the different areas like eyesight improving, sleep improving, less frequent urination. I mentioned that's just a matter of the prostate and also just convenience. And also the pain in the knees. My knees are so solid now that I can run up the subway steps without so much as a twinge of pain. That is, I mean, that kind of relief is really incredible if you think about it, especially, 64 isn't like super old or anything like that, but still, that's really impressive. So first off, congratulations, Joseph. And secondly, thanks for sharing. I appreciate it. Okay, and the final, those are kind of the three stories. If you like this kind of stuff, I get so many comments and so many emails from people telling me like, oh, I've started taking this because of your video and it helped me in so many different, like these different ways. And that's really remarkable. I'm incredibly thankful that one, that you share, but secondly, that I'm able to help in that way. But also, if you're interested in like hearing some of these stories in the future, in future podcasts, then please let me know, comment, and I'll be sure to add it in future versions. So the final thing that I want to discuss, I did mention housekeeping, and I kept that for last because for people that aren't interested in sort of housekeeping stuff, even though I've kind of sprinkled it in every once in a while in the video and in the podcast. The last thing is to discuss my PhD, actually. So I get questions every now and again asking me if I'm done with my PhD or when I'm finished and all that stuff. And a PhD is a really, really difficult thing. I went through a master's program, and that was really difficult in a very short period of time. It was 2 years, really intense, taking classes, doing research, teaching all at the same time while also working on Physionic. That took a lot out of me, but it was manageable. Like, I don't know, it was very manageable. A PhD, on the other hand, has been really, really difficult. I've had some great success, and it's been going very well, especially of late. And I'll describe exactly how in just a little bit. But yeah, just managing the amount of work, because I have to be more present for my PhD than anything else. That's of the utmost importance, and that's the way it's going to be until I finish. Now, when you're going through a PhD, you have multiple like trial periods. It's essentially like trial by fire almost. And in my program, it's especially this way. It is such a difficult program, which I'm sure on the other side, I'll feel fantastic to have gone through it and to have finished it and to feel really proud that I went through such a difficult program, but it has taken a lot out of me. And I'm sure I'm going to need some time to recover afterwards. But as it stands, I don't think I would recommend a PhD for most people. It's a complete different animal from a master's program. My master's, it just feels more doable. 2 years seems more doable, even though you have to juggle classes and research at the same time. And then I threw on teaching as well. A PhD is it's classes and then research separate. So they actually separate the two, but the research and the classes are full-time jobs essentially. And, I'll go over the details of how the different trials of fire that I've had to go through in the future. But for the time being, I have entered the sunset stage of my PhD. I finally had a conversation with my PI, who's the principal investigator, my mentor, and we finally agreed on a time for me to graduate. I'm definitely excited. I was really stressed, I think I would say, about the idea of graduating and then having to find a job, like a career. But of late, Physionic has grown substantially. Just in the last month, we've gained like 30,000 subscribers, which is, if you think in January, Physionic was at 25,000 subscribers. That was 9 years of work. 9 years of work to get to 25,000 subscribers. And I think later today, at the time of this recording, it will hit 90,000 subscribers. So we will have more than tripled in growth. And I can't express to you how potentially life-changing that is for me, because ever since I changed my style of how I've been doing videos, which, still try to be honest, always try to be intellectually honest and put my best foot forward and take my best foot, a step back when I make mistakes. That's always been the primary goal. But, it's just opened some possibilities, especially with the Physionic Insiders. That's been growing over time, and I've been really thankful for the Insiders. I love doing my live sessions with everyone, those people that can make it to the live sessions. And I've got some new plans for the Physionic Insiders, some additions that I'm going to be throwing in there. But yeah, I've been working my tail off, and it's just constant work. It's nonstop work. And don't get me wrong, I'm not complaining. I love it. I absolutely love it. But, just to have that, and then for the channel, let's say for Physionic, the brand in general, to be, let's say if it were like 30,000 subscribers this year, I would never quit it. I would never quit Physionic, but it's still a daunting task to think, okay, well, now I'm going to have to look for a full-time job. And then on top of that, have to still keep Physionic rolling, because I've never missed a week, and I never plan on missing a week of content. I always release content, and now I've got the Insiders, so I've been releasing content every week for the Insiders as well, or just about every week. I think it's every week at this point. And it's a tremendous amount of work. And like I've said before, it's a one-man operation. So while I get a lot of questions of like, hey, can you cover this? Can you cover this? And man, oh man, the answer is absolutely. I would love to cover all that. And I do think that in time, as Physionic continues to grow, I hope that one day I can have like a whole team of people to help me break down studies, and that we can release content at a much faster pace with even higher quality, with better video editing and all that stuff. Like I would love that. But as it stands, it's just me. So if it had just been me, where I have to find a job, which I would, again, zero complaints. I already know what I want to do. Like I know what aspect, like what kind of work I would love to do. And that's teaching. I've loved teaching. I've been a professor for a number of years now, during my master's, and then during my PhD, I carved out some time to teach physiology, and cell biology and health. And I have so much fun teaching that I can't imagine just not doing that in my life. So, no matter what, I was going to try to find a job. But it was, as Physionic grows, my point being that as Physionic grows, and as I near the end of my PhD, it's opened up doors to like a potential that I have some flexibility, that I can maybe focus more of my attention on Physionic and not have to worry about having to find a full-time professor job. Like I'd probably still have to find like a part-time position, which would be amazing. I would love to do that, to do a part-time professor job while also working for Physionic, or working on Physionic. And yeah, so now I'm getting to the sunset period of my PhD, and I'm just really thrilled. I'm just blown away by the growth of Physionic this year, and it really is a testament to how stupid I was in the past. I can't state I can't state that enough. Just how freaking stupid I was to ignore my personality. I've even had some backlash on like some of my videos of people saying like, well, scientists don't speak this way. Scientists don't like talk the way that you do. And it's like, yeah, okay. I mean, technically, I suppose that's true. A lot of people don't, but I am around scientists and they are really passionate individuals. And, now that I've injected more of my personality, or really just kind of unleash more of my personality in the videos, I've noticed that certainly that's led to significant growth, because I think people, again, they connect more with a person as opposed to data. And I have tried to find that balance of still approaching the data, trying to represent the data as it's supposed to be, while also still offering some nuggets of my personality. And it seems to have worked. It's always, I still feel like I always have to keep a leash on my personality, because not in a bad way. I don't want you to think like, oh, I'm restraining myself too much. It's just I need to make sure that the videos are still concise. They can't, well, other than the study analyses, those are hours long. Those are not concise, and they never will be. But the more edited videos, the way I write notes for those, to keep me on track when I'm talking about the topic, is I can't just derail things and just be talking about all kinds of other stuff for like 5 minutes and then come back to the data. So I have to put a leash on it in that regard. But I think that overall, that more authentic personality wise, not data driven wise, it's always been authentic in that way, but the more personality wise that I've been able to be authentic, has garnered more interest from people, which, I'm humbled. I'm always humbled. And I am always deeply appreciative of the fact that people are interested in what I have to say. And even when I say it certain ways, I'm certainly afraid of saying things that could be construed as negative or overly negative. And that's where one of the problems with expressing your personality too much can be detrimental. And maybe in the future I'm going to have to deal with that. I don't know. But as it stands, it makes the videos a lot more fun. It makes the content a lot more fun for me to be able to express myself and just have, man, I have such bad jokes. I enjoy the bad jokes. I enjoy the quirkiness. It is definitely part of my personality. And, some people get it, some people don't, but hopefully they'll stick around for the data regardless. So it's like 20% personality and 80% data driven, which is fun. But all that to say that because Physionic has grown so much, and I hope that it continues to grow, that it's afforded me it's afforded me a lower level of stress about what I'm going to do after my PhD. And my PhD, I'm a little bit hesitant to give a definitive date, mainly for when it will end, mainly because when it comes to a PhD, it's not dependent on you. You can't decide. It's dependent on what your PI says, your mentor, and what your committee says. And that actually leads me to my latest thing in my PhD. So my latest trial by fire. And that is a thesis proposal. So I had a thesis proposal defense. It's kind of a weird system when it comes to a PhD, but you do a bunch of work in the direction of a particular project. And then once you've done a little bit of work towards that, you essentially propose the future work that you're going to do based off of the foundation of work that you've already done. And that proposal is public, so people can come, they can watch. And the second thing is that proposal is in front of your committee. So your committee then decides if you're allowed to move on to the next step, which is essentially the final steps. Because the next steps for me, I have 3 next steps. I have to publish my first author paper. So the study that I am the chief author, the chief researcher on. So for my program, I'm required to have one of those papers. I've released some other papers, but I've been one of the middle authors. For this paper, I would be the number one, the main author. The second thing I have to do is I have to give a seminar on my work to the school. So the entire school is allowed to come, and it's I'm not too nervous about that. I think it'll be a fun experience, but it's essentially like a 45-minute to 1 hour presentation. And then you get asked a bunch of questions by the department. So a bunch of researchers will come. A lot of medical doctors will come because I'm in the PhD for molecular medicine. So a lot of medical doctors will come. And then they just ask you a bunch of questions. So that's the second thing that I still have to do. And then the third thing is to do the dissertation. So the dissertation defense. So I would start writing like 150 page document on all the work that I've done, and then put it together into a presentation to then defend that, to give a presentation, and then I have to defend that in front of my committee in a closed door session. Then they decide if I'm allowed to graduate. That said, my thesis proposal defense, which is very similar to the dissertation defense, I gave that, and my thesis committee was really impressed with my work. So I was on cloud nine, mainly because it's hard to juggle things, but they were genuinely really pleased and impressed with my work in my proposal. So I defended correctly. I defended well. So I'm really, really happy about that. And it just shows to me that, okay, at the beginning, things were really difficult, and they're getting easier and easier as I'm learning more, as I'm pushing myself further. My classes have been done for a long time now. They've been over for about 2 years now, or a year and a half. So I'm done from that aspect. But now it's just about actually going through the final steps of the research, and then I'll be graduating as a full-fledged PhD in molecular medicine. That'll be quite the day. But you can bet your butt that none of the I'm still going to be releasing videos, even if I take a bit of a break and give myself some room to breathe. I'll still have content releasing on Physionic every week, just like I normally do. But just wanted to give you an update. So the rough estimate is that I have about another year, and then I'll be done with my PhD, assuming that everything goes well. Knock on wood again. Okay, so I don't know how long this podcast has been. It's been definitely over 2 hours, maybe even 3 hours. I hope that you've been able to get something out of this. I don't get to do these very often, again, because time constraints. Sitting down for 3 hours or 4 hours talking about all the things that I've been covering, or that's not even all of them. That's like, 20% of the stuff that I've covered. It's not a luxury I have. I don't have much time on my hands. So I hope that you were able to get something out of this. And I think I say this at the end of every podcast, but I am deeply grateful for you. I feel like a lot of people say that, and sometimes I don't feel like they're actually being genuine. Some people I definitely feel like they are, but I'm building my dream. I'm building my dream, and I am always incredibly thankful that people are along for the ride for that dream to be a reality. And I can say that I'm proud of what Physionic has become, and I hope to always check myself to make sure that Physionic continues to be something that I can continue to be proud of, that still is in line with with my morals and my way of doing things, the quality that I expect of myself and those that I work with. So with that, I think we'll end it there. And yeah, thanks again for listening. Thanks again for watching if you're watching it. And I will hopefully have the pleasure of having your ear in the next one. Have a good one. Bye.